event is mainly focusing on toxicological intervention for industrial safety and sustainability. So this iConnect event, as you all aware, this is conducted as part of Azadi Ka Amrit Mahotsav celebration. The Ministry of Science and Technology and Ministry of Earth Science, Government of India, in in connect with the industry, particularly from May to August 15, and forge partnership with industries. The Science and Technology Ministry intended to draw upon the rich expertise and competence of government and industry leaders who are significantly contributed to the economic growth of the nation. As you are aware, CSIR IIT are mainly focusing on health and environmental safety. So, with the support of our director, Professor S.K. Barik, and the nodal director and the team director of our team of E3OW, Dr. V.M. Tiwari, it's great pleasure to welcome one and all for this event. Now, I request our director, Professor S.K. Barik, for his welcome address and inaugural remarks. Thank you, sir.
Thank you, Dr. Partho. Good morning, everyone. My colleague, Dr. V.M. Tiwari, Director, Team Director, E3OW, and all the colleagues, particularly, I believe, Dr. Chinmay Nandi, Vice President, Research and Development, NOCIL, Navi Mumbai, and Dr. B. Chakradhar, who is the head consultancy of Ramki Environmental Services, Hyderabad, and of course our many other industry partners like Dr. Alok Gupta, Dr. Ijar Hussain, Dr. Dhirendra Singh, and of course our whole IITR family and the scientists who will be talking, sharing their technologies and their experiences, vision about how we go about it. As all of us we know, let me first warmly welcome each one of you to this great event. As told by Dr. Partho, it is the ICEN-64 Industry Connect 64 event number. So we have come a long way since we started in the month of May, I believe, and we were the first in agri-nutribiotech theme that time we did. So today the another important theme, that is the ecology, environment, water, energy, so which is being heard by Dr. Tiwari. So I especially welcome him because under his leadership, this theme has been achieving new heights. And I'm sure the Industry Connect, like any other theme of CSIR or in the Ministry of whether it is Science and Technology, or it is the Department of Biotechnology, or it is Art Sciences. So you will see that this is a very combined effort from all these, almost all the science departments, science ministries. But yes, focus area is with the Ministry of Science and Technology, the three departments, that is Department of Biotechnology, Department of Science and Technology, and of course our Department of Scientific and Industrial Research, where CSR is a major player. So with these three departments in the focus, but in collaboration with other science departments like ICAR, ICMR, DRDO, Ministry of Earth Sciences, and many other science departments in the energy related, like new energy resources, all these departments, they are participating in this important Industry Connect. So why the Industry Connect? I think all of us we know, we science departments have very strong, whether it is the high level science, or it is the technology, or it is the product, but we do not have that outreach skill, nor we have that outreach, absolute outreach to the industries or to the people. So that's how the socioeconomic interface has been emphasized in recent decades. So CSIR and other departments of the Ministry of Science and Technology, we are now reaching to the people through various socio-economic line departments, ministries of Government of India and state governments. The similar way, the technologies which are being developed in our labs must go to the public, and we cannot take it to the public directly. It has to go through the industry. So industry becomes a major partner if we want to take our industries or technologies to the people, to its optimum utilization, whether it is export or domestic consumption. We need to take the technologies through industry. So unless industry becomes partner to our efforts, it is simply impossible. So that much of important role the industry has to play. Not that CSIR or our science ministry departments, they are not trying, but we have been trying in physical mode. Several industrial meets we have organized. Many of them have been also successful. One or two technologies have gone, but the level of, I should say, technology transfer that should have happened has not happened yet. So a lot of potential of CSR labs or DBT labs or DST labs are yet to be realized. So we need as much as participation of industry as possible. So starting from the big industrial houses with international presence to the MSMEs to even the startups, all are our stakeholders. With 37 institutions in the 8 thematic areas of CSIR, we have a wide range of technologies, wide range of patents, wide range of products. So some technologies are very high end, which is targeted for the export market, while some of them are targeted towards the domestic, even the MSMEs or even the startups, or even cottage industry also, or even SSGs also. So the technology domain of CSIR is so broad that each and every entrepreneur or industrial partner is important for us. So that is the objective we thought. More industry connect events we organize, our outreach to the industrial sector will be more. That is the precise objective for which our Honorable Minister, Dr. Jitendra Singh, visualized this iConnect event in a big way, and it was physically inaugurated in Jorhat. And subsequent to that, we have been doing it in hybrid mode in different places, depending upon the theme, depending upon the industrial houses presence, and other industry connects we have been organizing in hybrid mode. Sometimes big industrial personalities, they have been attending these programs also in physical mode. Many times they also connect with us over VC. But we have been really thankful to all these industry people who have been giving us support all these months, almost 3 months now. Coming to our present theme, of course, Dr. Tiwari will elaborate, but I will just speak a few words about our today's nodal lab, that is the IITR. CSIR is one of the important labs or institutions which has a unique niche nobody else has in this country. Even in the global level also, hardly 5 or 6 such institutions exist. So what do they do? So the scientists of this institute are known for their unique niches in the form of, name is toxicity, so naturally toxic assessment is there, but in the what matrices? You will see that all across the matrices, whether it is environment, or it is the human health, or it is the animal model, everywhere you will find that IITR has left a footprint. Not only that, it is progressive in nature. Say for example, before the world goes into the 3D models, CSIR, IITR is already on the job, and I am sure within 1 year we will have a success story. So it is a dynamic institution where we take off the cutting edge research. It is not just to assess or monitor the toxicity in those matrices which I said, but it is more important the methodological breakthroughs and the development of technologies, new technologies, which will ease our task in assessing these toxic elements in the different matrices. So we develop the new sensors, we develop the new methods, which will have more accuracy than before, as well as it is the cost effective and feasible in the field. Because you know, India has a vast country with multi-dimensional problems to address from the big cities to the village level. So we need to have those equipments, we need to have those robust methods which should be suitable not only for the big metros but also the far-flung areas where you cannot travel even by a vehicle. So big equipment you cannot take. So we have the methods of assessing the environmental pollutants or toxic elements in different matrices in those areas as well. So CSR IITR, with its very intellectual scientific capability, we have at least 16 models for which we try the different toxic elements and name any protocol. I think in India, IITR will say yes. Whether setting the standards, as you know, whether it is the FSSI in the food matrix or in the environmental sector in the Ministry of Environment and Forest or Central Pollution Control Board, setting any standard for any pollutants, CSR IITR has been playing a very crucial role, and the regulatory toxicology division of our institute has been contributing a lot in setting the standards in the human health sector. So whether it is the food matrices or it is the regulatory toxicology or it is the contributing to the policy development in this particular domain, or it is the development of new technologies, new protocols to assess, to monitor the toxic elements or toxicity in the different matrices. And also the latest is the toxicoinformatics research. So that is the growing area, the predictive science. Can we predict, given the past and present trends, what will happen to the future? So that is the latest addition to our institute, where the scientists are involved in high-end modeling and to predict if the toxicity can be assessed in predicted and also can be mitigated following the different cutting edge modeling techniques. So I must say that CSR IITR not only has been contributing the India's toxicological scenario to mitigate it, to make our life safe, free from toxic elements, uh, or industrial safety, the theme of this particular program. How to really ensure the industrial safety has been the focus of this particular program. So what is that? Yes, industries meet us, industries discuss with us for all these things what I said. So we also seek the partnership of these industries to develop these methodologies, to customize this if we are lagging somewhere behind. With their suggestions, with their practical knowledge, we improve our equipment or the protocols. And also we work as a mediator between the industry and the policymakers, because we have been contributing substantially towards the policy development, be it in the nano or be it in the any other toxic elements, or it is the setting the standards. So there also we take the message or views of the industry partner of our industries that should be heard by the policymakers. Well, coming to the industry safety, it cannot be overestimated, no, underestimated, because the safety first. So environmental risk is a problem not only for the workers who are involved in the industry, but also to the people in the surrounding area or in the downstream of the, the landscape or waterscape, whatever we are talking about. So the safety is the first, and hazardous risk assessment and mitigation, that is important. So for that, alone the scientist in the lab cannot really develop the realistic solution to the problems. So we anticipate whatever technologies we have, which the scientists will be presenting, but also we need their partnership in identifying the problems, understanding the problems in the right perspective, then developing the mitigation measure or the protocol or the technologies or equipment, whatever we are going to develop, it will be far better for the market, for the consumers, if we freeze or we develop partnership with the industry. There will not be any gestation period to take it to the market, or for its patentability also it increases. We have a very favorable environment. We share all the benefits, whether it is the industry or other academic institutions or scientific institutions, equally the credits, whether it is the publication, patents, or technological benefits. So we invite industries to be partner with us. Let us customize it, whatever the country needs, the customers need, the domain needs, so that you know better than us. Your market intelligence is far, far effective than us. We have several partners, we have several mechanisms. Say, for example, Bionest, Dr. Partho will be talking about that, or the DSIR program on the environmental pollution monitoring, and how we have provided a hub for all the industries. They should come, incubate their technologies or our technologies, and then actually standardize that and improve that and go back to the market again. Or it is the pollution monitoring total setup which we have in IITR. We invite them, come see and also start your startups. If you are a beginner, we will welcome you. And we have the incubator or hub, whatever you name it. It is very, very reasonable price, and I think that message also should spread, so that the truly the whether it is the DSIR or it is the DBT's objective of setting this hub at IITR will also be fulfilled. With this, I once again welcome each one of you. We dream big, but yes, realization is difficult, but it is not impossible. If industry becomes partner, if other departments, other ministries, other academic institutions become partner, I think this is much easier to achieve, and certainly we will achieve the dream of Atmanirbhar Bharat, because we are developing the technologies, we are developing the protocols, we are developing the science for our own people, and I'm sure we have enough capability, but we can realize it with all our partnership. And I think iConnect is a right step towards that, and with industry, we will forge partnership through this event. With that, once again, I welcome each one of you, and let us see the whole day. After that, we should be enriched with a partnership development. MOU signing might be, opportunities will be there in future, but today we can understand each other, and where potential lies, we should be very free and frank in discussing. Our technologies are, many of them are matured, but still they need improvement. I think we seek advice from the industry how to improve those also. With this, once again, I thank you. Namaskar. Over to you, Dr. Partho.
Sir, thank you so much, sir. Thank you so much for setting up the stage for the event today and highlighting the significance of our institute and providing guidance for how we can connect with the industries. Right now, it's a great pleasure to welcome Dr. V.M. Tiwari, team leader and director of National Geographic Research Institute, and he is pioneer in environmental research and geoscience research. Sir, we are very happy on behalf of CSIR IITR. We congratulate you for the award recently you received for National Award for Geoscience Technology for the year 2022 from Ministry of Earth Science, Government of India. And it's great pleasure to welcome you, sir, for our event. And over to you, sir.
Congratulations, Dr. Tiwari. Before you start, I forgot, sorry. Congratulations for this great achievement.
Thank you, Dr. Bari, the Director CSAR NBRI and CSAR IITR, colleagues from CSAR IITR, other CSAR laboratories, and from outside laboratories, friends from academia and industry.
697.
I will join Dr. Bari to welcome all of you for this iConnect event, which thought of for a long goal, and also to certain extent achieving the target planned in the these kind of events. Dr. Barik had very exhaustively talked about how environmental toxicology will be important for the safety of the industry and also safety of the people outside industry. I would like to emphasize the point that in the present day, the environment, water, and energy remain in forefront, though it has been since the dawn of the humanity, but now it has become much more important because of seeing the health of the human being, animal, and our planet Earth. I would like to also draw your kind attention the importance of this event, that this is being planned, this is being executed for the industry and bringing the industry for solving the bigger problem of our country, bigger problem of the people of the country, and also at large extent to the humanity.
Input level.
Could you please switch up your mic? I'm very pleased that we have a good number of industry partners joining today for this event, and also to see the one of the colleague from Hyderabad, where CSAR NGRI had worked for how the environmental impact assessment can be savior to the pharma industry. We worked with the pharma industry, seeing that how the toxicological or effluents being discharged outside the industry can be managed in the way, and if we see the impact of that, it's in the hundreds of crores of rupees. So one side we are talking of the health of the people, health of the planet. Another side we are talking of the prosperity of the people, prosperity of the nation. And this cannot happen alone, as had been emphasized by my colleague Dr. Barik, that we need to come together ourselves from the CSAR, from other science ministries, academia, and of course, industry, which will have the benefit for all of us, for the benefit of the economy. I don't need to emphasize much more on this point, but at the same time, I would like to appeal all of you who joined on today's event that we must realize that the present day environment of doing science and involving scientists towards problem solving is the best. And therefore, we take the advantage which will be beneficial for all of us. And I really find it this this event I-64 of a lot of relevance, particularly when we are thinking of uh, meeting the demand of the bulk chemicals in coming few years or few decades. When we are thinking of our pharma companies to have the drugs, which majority of them we import from outside. We are thinking of the contaminations and pollutants which are sometimes geogenic and sometimes anthropogenic to have the potable water and also quality of food. And therefore, the connection to industry, connection to the society, connection to the younger people who will be our backbone in future are very important. And I congratulate of thoughtfulness of our colleagues as IITR of designing this program, bringing industry on board, and look forward for deliberation of today so that we can, as Dr. Barik had pointed out, having our technologies in E3OW for water, for environment, for desalination of water, for management of the toxicological effluents, management of the wastewater, management of the other environmental impacts like air pollutions and so on, can all be used for the solutions for the problems which today being faced in the different parts of the country and different parts of the world. So I wish very good deliberations and will be very happy to take lesson from this so that we can further enhance our efforts towards connecting to the industry and also deploying our technologies for the betterment of the people. Thank you very much. Namaskar. Jai Hind.
Thank you so much, sir, for your valuable words and leading us in our one of the important theme of ecology, environment, earth, and ocean science and water. So, as you suggested, definitely we are making the partnership and the right partnership with the industry to provide a valuable solution to them and setting up the stage for how we can connect and work very closely together. That's what we are currently planning in a platform. As Professor Barik suggested, we are setting up some of the industrial platform at CSIR IITR to take them on board, provide very, very relevant solution to them at this current situations. And thank you again, sir, for sharing your valuable time. So to move ahead, now I welcome Dr. Nadesan Manikam, Chief Scientist, CSIR IITR. He is the leader of environmental toxicology research and pioneer in environmental microbiology and toxicology for the past 30 years. He developed very basic science to applied science from lab to land technologies on bioremediation. And he is currently heading this environmental toxicology division and providing various technology development and guiding us for our DSIR environmental intervention hub and different activities at CSIR IITR. Now he is guiding us for connecting with industries also, like how we can work very closely together. Now I will inviting him for his talk on intervention in environmental toxicology. And over to you, sir.
Okay, yeah. Very good morning, all of you. Thank you, Dr. Partha, for those kind introduction. Definitely, both Professor Barik and the team nodal director, Dr. V.M. Tiwari, has already set the tone for the entire day, giving the thrust what at CSIR level, national level, ministries, and of course, CSIR IITR is ventured in achieving various research issues leading to technology development under the theme E3OW. All of you must appreciate in this context, globally, this theme is most spoken about because you cannot imagine the world without water. Of course, what I mean is good quality of water. The air we breathe should be of good quality. Of course, the earth we live should be free from these toxicants. So E3OW is very, very integral part to all the other technology or science we carry out globally. So, sir, I must tell under the dynamic leadership of Dr. Tiwari, this particular theme has taken or realigned with the national requirement by rethinking, reshaping, and reimagining our research. Whatever we do in the institute level, we have already aligned with the technology development partners, stakeholders, industries, as our director was emphasizing, that large number of industries now look forward to joining hands with IITR in smaller startup initiatives or incubating with us in certain facilities created, of course, spearheaded by Dr. Partha in creating some centers. But I must put it on record, large number of younger colleagues who have joined in our institute has readily volunteered to offer their expertise, work, aligning with the theme, which will address what you call reduction of pollutants, the very monitoring of residues in different matrices. As Director Barik said, IITR has capability of developing methods and analysis tools, etc., etc. Also, that in water we do extensive water quality assessments, not only for groundwater, it's also for the river waters. So good capability is there, and large number of our scientists play a major role in regulatory bodies like BIS or even capabilities in plastics, etc. So IITR derives support and research leads for this particular theme, that is water, ecology, environment, earth and ocean, from large number of our scientists who are working in the different domains of it, but they pitch in readily to support this. So let me talk through the slides now. May I request my colleague to switch on my slides. The eye connect is very, very key, as like Azadi Ka Amrit Mahotsav facilitates sharing whatever the scientists doing a hard work in a laboratory ecosystem should see the end of the light, or bring that into a public domain where industrial partner can be enrolled, aligned, or we arouse their interest for coming and joining hands with the research institute like IITR. So before coming to the technological focus, let me talk about what on environmental toxicology we do. We at IITR focus on, as I said, this E3OW, many aspects we work on. Of course, air quality monitoring, both indoor and industrial setup, like EAA assessment, environmental impact assessment, water quality assessment in different parts of the country, including major rivers, where we need to provide the ground situation, physicochemical properties, even microbial qualities. And all of you will appreciate that once a chemical is manufactured in any part of India, bound to come into environment by use or agriculture practice, or even as a date expired sample. So we need to monitor their presence, load, who is there, how much is there, what is the abundance of those chemical in different matrices. So essentially the thrust areas of environmental toxicology, some of the glimpse of it I put it here. Of course, as an R&D partner, we work on understanding the adverse effect of toxicity of different pollutants, be it a synthetic chemical or even the biological toxicants. So we do work on their adverse effect using several model organisms, both vertebrate, invertebrate, and those scientists also partner with other scientists like neurotoxicologists, reproductive biologists, endocrine, reproductive issue scientists. So they all partner and work on this, understanding the holistic effect of these adverse chemicals. Of course, as a technology providers, scientists like Dr. Partha introduced me, working for more than 25, 30 years. Once we work on certain aspects of, even core research, how to make them work in a real situation, in real life situation, so that actual protection of the people who get exposed to these can be prevented in a real community situation or in field conditions. So we do work on that. Ecotoxicity and environmental monitoring is a major thrust in our institute. Of course, this forms a major role in E3OW, be it at ocean, marine situations. Like, these days, this E3OW will be more felt as a large number of forests are under fire. Climate change is very rampant. The climate 2-degree change occurred in 50 years is happening in 20 years now. The faster ice melting is felt all over the globe. So that's also very alarming situation. Climatic disturbances, rain, havoc. So all these things are being felt. So water quality assessment and contributions to national mission. For example, IITR very readily pitched in and joined hand with the missions like Swachh Bharat and Namami Gange. So IITR continue to play a role because our founder directors and forefathers created a plethora of interest and technologies where we already worked on such calamities. So that actually boosts us to contribute more. Of course, in all this endeavor, we do create some centers of excellence like CRTDH, Bairak, Bionest. This my colleagues will speak in detail. Fortunately, we have lectures in brief by all my colleagues emphasizing more on these aspects. So let me move quickly. Of course, as I little bit talked about climate disturbances, we do not recognize as a holistic view that India is really, really, truly blessed with rich diversity. I, I know, like Dr. Tiwari already spoke on various platforms, emphasizing how E3OW can serve into different areas. Himalayan resource, Himalayan the biodiversity, Western Ghat diversity until even Sri Lanka, Sundarbans, they are all highly, highly appreciated, protected biodiversity hotspots of the globe. That's why you might know that India is already a signatory in Cartagena Protocol, where we come under the mega biodiversity nation. So we need to protect these endangered species, plants. I must tell, as we are talking, large number of marine species are getting extincted. Their food web or the trophic cycle is being disturbed because of the water quality we send through various rivers into ocean, the chemicals the residues go into the ocean, and of course the climatic disturbance. Various international platform also recently discussed about large number of marine species moving from warmer ocean to colder oceans. And imagine if that happens, these ASEAN countries or Southeast Asian countries will have to be less dependent on these marine food sources. So there is a big alarm. So we have a lot, and this brings, of course, this brings a lot of challenges for scientists to address these issues and deliver technologies and scientific outcomes to protect this one. So as Dr. Tiwari pointed out, the prosperity of the nation depends on good quality of water we drink, because like COVID or disease endemics we discussed, diarrhea and cholera still kills more children and elderly people when compared to large number of other diseases. So we need to provide water, good water. Air, of course, need to be explored for minerals and resources in a controlled way. And of course, ocean need protection. Environmental toxicology, essentially, we not only work for the adverse effect on living organisms, individuals, a community, and an ecosystem as a whole. So this brings our focus on various sustainable development goals. If you see the 17 SDGs brought by UNDP, the first one is poverty alleviation. Of course, everybody needs to eat. Of course, when they talked about the first SDG as poverty, second one talks about no hunger. After that, everything falls under the E3OW theme. Let me put it that way, like, taking the credit for this. Because good health, affordable green technologies, energy, of course, the initiatives in industries these days, no real estate industries are blooming. So constructions and construction mediated disturbances, air quality and debris which are brought forward and energy being utilized, all these need to be addressed. So we can have intervention in all this. Of course, climate action, our government under the leadership of Honorable Prime Minister proactively involves in various signatory events, and we need to, India will have an increased role, enlarged role to play in climate action. And of course, life below the water is very, very important. As I said, the marine resources are shrinking and marine food need to be protected. Life on land, of course, you see, the moment we produce more textile, dyes, metals, all other agrochemicals. So these lands are getting disturbed. Like prospective farmers in Punjab or even Haryana, there are cities named as cancer cities. Imagine the greed for producing more implicate the health of the people, and a train runs to Bathinda to Jaipur is known as cancer train. So you see, prosperity is one hand, development goals are another one, but people's living, children's health, and disease prevention is very, very key to be, assessing a nation's property. My colleagues may be highlighting on it, Dr. Srikanth, Dr. Kisku, and Dr. Khan, but the prosperity of nation in global scale also measured in the air quality index, for example, AQI, and a large number of different yardsticks and parameters are assessed to name nations ranks. But out of 30 cities, 21 cities in India is worst affected in pollution index. So we need to work on that. So air quality need to be monitored and worked for devices. Fortunately, some of our younger scientists are working on this aspect, bringing in development of even devices, tools through better, project mode. So they are all going to deliver, and they have already aligned into E3OW theme. And contaminant residues has to be monitored and prevented entering into our seas and oceans and even river situations, river water streams, resources. Site reclamation restoration is very key for protecting the communities who come directly exposed to it, and of course, conservation of biological diversity. This one slide speaks about the industrial partners who are there. Dr. Chakradhar and his company Ramki Place is one of the India's largest company addressing treatment of not only wastewater, the solid waste management in and around Hyderabad. They have taken the government contract from state government of Telangana and Andhra Pradesh. They extensively recycle and work on abatement technologies, making them non-polluting entities, and of course converting them wherever possible, making them manures and enhancing the agriculture productivity. And Dr. Chinmay and their company, who are the largest rubber manufacturers, NOSIL, which is the National Organic Chemical Industries at Mumbai, also involved in various such interventions. I think they will highlight it. And see, not only these classical pesticides, pyrethroids, organochlorines, organophosphates, large number of these like plastics, of course, but a large number of other PFAs, antibiotics, halogenated chemicals, UV filters. India is being a dump yard for majority of the cosmetics globally produced. I must tell that these large number of these UV filter chemicals, which are organic, many of them are organic in structure, very what you call active. They have active structures which can be photo cleaved into toxic product when they come into environment. So all these emerging chemicals come into environment. We need to at least monitor in various water bodies, soils, the water we drink. Is that free from all of this? Not many, all of us are affordable to good water quality, at household level. So large number of our people, at least 33 million people living on the Ganges River alone, the belt, the banks of river supports a large number of population. If these waters are contaminated with such cosmetic products, personal care products, steroids, hormones, as a toxicologist, we know better that they are endocrine disruptors, neurotoxicants, and whatnot. So we need to work on monitoring, assessing, profiling, mapping all those in different matrices. Of course, once we do not do any control on this, wastewater being utilized for actually recycled properly, as we talk, I must put it on record on the lighter side that large number of companies are now shifting who are beer makers and breweries. The Alberta is one company who produced beer from wastewater. It may look like yucky, but large number gallons and gallons of waters are required. Good quality waters are required for beer making with minerals enriched. So people are competitively working on utilizing those wastewater for breweries. So that those are the interruptive or disruptive technologies we should be thinking of, and particularly in India, where sometimes we get good rain, but all the years we do not, all the seasons we do not get good water. So we need to work on all those things. So of course, my colleagues are there who develop CRMs and work on regulatory regimes, providing large number of big data derived from various toxicological studies for setting permissible limits in various like BIS, MOEF, or CPCB, or even other regulatory bodies. So our toxicological output data derived from hardcore experimental studies using animal models, and of course the data derived from environmental studies are very key to nation building. Of course, I talked about this. We have capability to do all this analysis of all these compounds. We do undertake because of this microplastics and plastic, where six major groups like polystyrene, polyurethane, polyethylenes, large number of these breakdown chemicals go into seas. Of course, wherever we use, even Lucknow, we have three major dump sites. Like one site is at Gaila, about 30 kilometers away from our institute. This concatenation of all the chemicals, household, municipal waste dumped, including plastics, hospital waste, and large number of other chemicals, brings those chemical leachates into directly Gomti River. And of course, all of you know Gomti joining the Ganges after say 50 kilometers downstream to Benares. It makes a local problem into a national problem where these chemicals are taken into river. So we need to monitor, understand. For example, we did a small pilot studies like what kind of plastics already reached this marine ecosystem or water ecosystem. These are major fibers. Of course, we filtered and understood what are the minor debris which are less than 5 millimeter in size. We call it plastic debris or microplastics, things like that. So we need to understand, because as we talk, these microplastics have reached our table salts as per the IIT Mumbai studies, as it has reached the human placenta as known in Western literature, like recently Lancet and other journals discussed about microplastic present in placenta and of course various other human tissues. So it is very alarming. We may not see it, but often, but it is very necessary to undertake what are these kind of disturbances coming into ecosystem, ultimately coming into environment. We do undertake IITR monitoring of the functioning and efficient release of this wastewater into river bodies. For example, a largest STP in Asia is located at Lucknow. The place is known as Barwara, where 345 MLD capacity is there. A huge pump brings gallons and gallons of, as I said, 345 MLD water into this treatment system. But when we IITR programmed, we undertook the chemical profiling of it. Of course, the bacterial load, the pathogen. So I'm not going to detail about the research we do, but large number of antimicrobial resistant development is happening now. Large number of bacteria which are not known to be pathogen in previous, say, decades, like 10 years before. For example, 10 years before, a scientist came from Sweden, came to Delhi and took water, and that's how this Klebsiella pneumoniae, which is known as a multi-drug resistant strain, not treatable with any antibiotic, named as very controversially NDM1, New Delhi metallothione resistant or multi-drug resistant strain, Klebsiella pneumoniae. So, but we did undertake such sampling, and also in the river, where upstream before this water falls and downstream after this water fell into the river, large number of pathogens showing multi-drug resistant to even the latest antibiotic classes like macrolide, which has been used, or like MTB for tuberculosis treatment, we use rifamycin. Large number of it, huge antibiotic load, and rifamycin wastes are coming into water. We detected it, but then this MTB, which is showing rifamycin resistant, has become resistant to many of the antibiotic classes. As I said, sulfonamides, macrolide, microlides, and other beta-lactam groups. So we need to be very cautious about what is the treatment efficiency in currently available. Can scientists play a role joining hands with a institute like IICT or even like CMS, RI, Marine Salt Research Institutes, even drug research institute like CDRI or NBRI planting, large number of filtration, rhizospheric filtration plants along Ganges. So large number of multiple interventions are required as this topic is being discussed, like environmental interventions. Huge role has to be played. Of course, in the technology partnership, IITR has all these organisms for testing of chemicals, as we are talking about the industry participation. Dr. Chakradhar and Dr. Chinmay Nandi from NOSIL have already expressed their interest to utilize these systems testing some of the chemicals. Some of the chemical derivatives they are synthesizing for rubber at NOSIL. They want to come into IITR, work on initially predictive toxicology, predictive computational tools for testing some of their chemicals, so we can enroll them effectively in utilizing such facilities. We did undertake certain remediation exercise where one of the notorious cancer-causing chemical, which is lindane, which has other three isomers, which they are stereoisomers with same molecular structure, but cancer-causing chemical, alpha ACH, beta ACH, delta ACH, which is about 30 kilometers down Lucknow, a village called Umari. 7 villages have been drinking water surrounding these hand pumps here. We have detected ACH presence in hand pump. We have detected in buffalo milk. Of course, even people have detected in goats and even human milk. So this chemical is cancer causing. With the support of Professor Ruplal from Delhi University and Dr. Professor Barik's guidance, we did undertake such work for biological remediation, which includes bacterial and plant phytoremediation processes. So we did converted that very toxic load of such situations where about 3-meter depth of chemicals were obnoxiously, we can't even stand on that site for longer time. So we converted them into some sort of green belt. Work is still on. So we converted them by thereby protecting the people living in such situations. Also, IITR joining with few more institutes are working with the remediation tools and methods we are providing through biological source for treating ONGC oil sludge at Ankleshwar at Gujarat. So our chemists, our biologists, our friends from environmental sections, they all work on this. So and these such technologies once are available, we can implement it in wherever it is possible. For example, that Prince Alaska spilled Exxon Valdez gallons and gallons of millions of oil. But here, for example, in Chennai, about few years back, and in Mumbai coast, a Chitra ship collided, spilled large number of crude oils there. So after harvesting them with sawdust and sponges, we can also introduce some effective bacterial consortium to remediate those oil. They feed on those oil, utilizing as nutrients, and then we can eliminate them. Yeah, one of our other colleague joining hands with the chemists and others developed technologies and treatment systems for breaking the paper and pulp mill waste, effectively removing lignins and of course other the phenolic compounds from wastewater like paper mills. So these technologies are also available for industries to implement in their resources. Of course, this Namami Gange, we were part of it for monitoring them, both microbial diversity, antimicrobial resistance, metal resistance bacteria, of course, exploiting some of the biological source available in Ganges for novel enzymes and pathways. So IITR has major role in this, and we have extensively worked on monitoring these 4 rivers for exploiting the potential available for treatment of several ways. So talking about the IConnect even little more deeper, that IITR with the effort at the leadership level brought in this CRTDH, which is Common Research and Technology Development Hub, joining also hand with Vairag Bionest. We incubate some of these facilities, the knowledge available, the key machines and tools available in under one room. That's what we call it as hub of our center of excellence. So we create a platform, a pavilion where any incubatee, a person who has a commercializable or thought process or technological ideas, they come and claim a space, and we provide them not only infrastructure, machines and tools, of course ideas then and there. So they can incubate with us in these 2 centers for developing technologies which can see end of the light. So we do impart all this knowledge through Skill India program, infusing the youth to understand about these technological requirement, scientific knowledge, so that the young minds can capture very fast. So they can join. So we do undertake such programs under various our HRD head and Skill India people to impart this knowledge. So we do IITR, as Director Barik said, a large number of industrial conclave and meetings for telling about IITR's vision and role. Not IITR alone. We showcase in these platforms about CSIR's role, team like E3OW's role, and our objectives to all these industrial people. So that also act as a interface between industry and researchers. So today, for example, to share their success stories or alignment with IITR, two of the industrial partners are there. There are more that Parsarthi enrolled. There are more industries joined, and time to time we enroll them for other events like a MOE signing. They will talk about some of their key salient achievements. National level they are playing for E3OWT. They will share today. I think with that I will stop, because large number of our colleagues going to speak in each one of them in a little more elaborate way. I think Engineer Khan and Dr. Srikanth, and later on Dr. Khanna and Dr. Sharma will share their in views, of course with the inputs from Dr. Kisku, who spearheads the environmental monitoring division. They all will tell about a little from their side how this E3OW theme is being emphasized or given trust and rethought. And as I said in the initial, under the leadership of Dr. Tiwari's support also, E3OW has taken a leap forward in rethinking, realigning with this work what we do at the national level. Thank you, Dr. Partha, and thank you all for patient attendance.
Yeah. Thank you so much for sir for briefly covering our IITR activities, and have more time in our panel discussion, so we can discuss about like how we can take these technologies forward, or take some of the identifying some of the essential need in the particularly environmental pollution abatement sectors and waste management sector will discuss during the time. Right now, I'll invite Engineer A.H. Khan. He is one of our key member in our environmental monitoring division. He is also having more than 30 years of experience in environmental monitoring and various air quality assessment. They did a lot of services to the industries as well as various societal activities, including a pollution survey of Lucknow city. So now I invite him. He has a rich experience of working with policy makers and CPCB and various membership on various committees. I forgot to mention that CSIR IITR scientists are playing a major role, including Dr. Manikam. He is in various national committees as well as international committees in this environmental sector. So Dr. E.R. Khan also serving in various committees with the policymakers that will enable us how we can strengthenize the industrial safety point of view as well as national needs. Now I invite Engineer A.H. Khan for his talk. Over to you, sir. Okay. Slide load.
Good morning, everybody. Thank you, Dr. Partha, for my introduction. So, Dr. Manikam has very broadly covered the areas of the institute, and one of that is air quality monitoring and services, what the institute is providing to the industry. And in general, we are conducting different kind of studies covering various aspects of air pollution. Next slide. So, fine. So,
I do for you.
no, no, thank you. So the mandate of our institute is safety to environment and health and service to industry. So that includes the entire requirements, all the requirements of today's world, wherein we are there. So the institutes provide these kind of different kind of contaminants analysis in air, water, food, plastic, polymers, engineer, nanomaterials, etc. I am just covering the air pollution part because we are doing different kind of studies in relation to air pollution, regarding air pollution. So the particulates, the pollutants which are in air includes particulates like particles of size PM 2.5 and PM 10, different gases like SO2, NO2, ozone, ammonia, and so many others. Heavy metals are also there because they are coming from different kind of industries and activities. There are organic compounds that includes benzene, benzoate, pyrene, pesticide, etc. And one more thing which we are doing is asbestos analysis in the asbestos producing industries, as well as where there are some old asbestos structures are removed, then there are pollution of asbestos. So we are covering almost entire range of the air pollution in this. So we are addressing our studies in industrial setup, that is industrial air pollution. So in industries, we conduct stack emission for all the parameters which are there in our Indian standards by our regulatory bodies. We are conducting fugitive emission studies in the industries where large of dust particles and other hydrocarbon in case of refineries and all are there. And we are also doing general work area environment of the industry. So we are completely addressing the demands of the industries, industrial air pollution. In case of urban air pollution, there are number of sources of air pollution in cities also, like refuse burning, biofuel burning, and for cooking in the slums area. Vehicular emission is a major source. So we are conducting air pollution study in Lucknow city, and where we have findings with us, and based on those findings, lot of interventions and improvement steps have been taken by the Lucknow administration and otherwise also. So we are covering all the aspects of air quality, including ambient air quality and particularly indoor air quality. We are also doing studies for some indoor environment, air conditioned environment like shopping malls and schools, offices, banks, etc. There is one more important parameter which govern basically the air quality or air pollution status at any point, that is meteorological parameter. So we have all facilities for the monitoring and analysis of meteorological parameters like wind speed, wind direction, temperature, relative humidity, rainfall, solar radiation, etc. So entire range of air pollution monitoring assessment we have with us, and we are providing our services to industries in a big way. For this purpose, we have all the equipments which we take to the industry or sampling site. That includes for stack emission monitoring instruments like flue gas analyzer, which directly measures the emissions from the stacks, stack monitoring kits for other parameters. For noise measurement, it is noise level meter. For air quality monitoring, we have fine particulate sampler, respirable dust sampler, and other online equipments where we can measure directly the pollutants, or we can collect the pollutant and do the analysis in the lab. For indoor air quality, we have dedicated equipments where we can measure direct measurement of pollutants, as well as for bacteriological analysis, because in indoor environment there are bacteria and other microorganisms are there which do affect the health of the people, and where people spend lot of time, say 8 to 10 hours in an indoor environment in offices and other workplaces. So that is all we are doing. So we are covering all the domain of the air, where air quality is important. Further, whatever samples are collected by environmental sampling, that we have facilities available in analytical chemistry division of the institute, like gas chromatography, HPLC, GCMS, MS, AS, direct mercury analyzer, atomic fluorescence spectrometer. So I think entire range of hydrocarbons or pesticides, then metals, toxic heavy metals, everything can be done in our institute. So We are working in close association with analytical chemistry, and we are able to provide all kind of these services to industry. So here I would like to mention few of the very important industries we are doing work for them. NTPC Limited, almost all the plants of UP like Singrauli, Rehan, Uchahar, Dibyapur, Korba is in Chhattisgarh, and Meja Urja Nigam in UP. So we are constantly and regularly working for them for the consultancy and testing services to NTPC. In addition to that, thermal power plant of Uttar Pradesh, UPRVNL, like Obra, Anpara, Paricha, Panki, and Hardwagan. All these plants we are working. Our team is going there and conducting all kind of studies like environmental audits. We have also done EIA studies for a couple of these plants, and the post-project monitoring, which is required for regulatory purposes by these plants. We are also catering our extending our facilities of these services to in Tata Motors, that is in automobile sector, Grasim Industries, and another Renu Sagar Power Plant, ITI Limited, Malkapur, Ordnance Factory, Korba. And we have also done indoor study of UNICEF office of Gomti Nagar. And we are also doing this asbestos analysis for Assam Roofing and Northeast Thing Limited at Guwahati. And there one important study we have also conducted, that is for BSF Tekanpur, Gwalior. So we have measured the impact of chili grenade which are burst in the open field, and we have measured the change in the air quality parameters while they are bursting these chili grenades. So different, we have covered almost many types of scenarios and cases for air monitoring services. One more field which is very important is occupational exposure. Like we have petrol filling. If you see, there are fumes of nowadays benzene and other hydrocarbons. In case of asbestos, people are exposed to fibers. So we can do all these studies for work area like pollutant, particulate measurements, gaseous pollutant measurements, asbestos, as I told you earlier. So here source identification control measures are important, for which we also provide them assistance and provide measures to them. Other intervention measures like health surveys, epidemiological studies, pulmonary toxicity. Other groups are also there in our institute who are looking after all these in our association. So now there are industrial safety rules are implemented, and most of the industries are trying to follow them because they are very strict rules. So we are working in this field for providing lot of training to these people in industry as well as to others. So our group is involved in skill development program in a big way. We are regularly conducting training programs for CPCB, Ministry of Environment, Forest sponsored project to the scientists and engineers of the CPCB, State Pollution Control Board, in various fields of air monitoring like ambient air and stack monitoring techniques. We have also conducted number of hands-on training, monitoring of PM 2.5 and other notified air pollutants as per revised NAQS, wherein 12 parameters, very important parameters are there. That includes a large range of sampling and analysis procedures and pesticide residue analysis in the environmental samples. So our institute is imparting these training to industry people, regulatory bodies, people from regulatory bodies, as well as academic and students. We have also organized a special training program to Maharashtra Pollution Control Board on advanced analytical instrumentation techniques application in the area of environment. So all the components of environment requires these kind of advanced analytical techniques to measure properly and use them for regulatory purposes. We have also done Skill India development programs of Green Skill Development Council, that is of Ministry of MOEF and CC, on air and water pollution monitors. Another program which we are regularly doing is Life Science Sector Skill Development Council program on environment, health and safety manager. So regularly we are conducting this program and trying to make them people learn how to analyze these pollutants properly so that the important decisions can be taken based on the analysis. Our facility is also NABL accredited and we are also conducting trainings for that also. I thank the organizer for giving me this opportunity to present some of the work what we are carrying out on this platform. Thank you very much.
Thank you so much, sir, for covering our broad activities on air quality monitoring and services and connected industry. So now I welcome Dr. B. Srikanth, a scientist, CSIR IITR, working in environmental monitoring division. He is one of our youngest colleagues and coming with the capability of both academic and industry. So he has a well-trained in IIT Mumbai, then he moved into industry. Now currently serving CSIR IITR for past 2 years and now leading several activities in the area of air pollution monitoring and quality assessment in the industries, as well as some of the technology development. Because there are a lot of gaps exist in the current technology of this air quality assessment. And he is currently working on developing technologies apart from his service sectors. Over to you, Dr. Srikanth.
Thank you. Good afternoon, all. Thank you for giving this opportunity. In continuation with the services provided by Environmental Division of IITR, so I would like to emphasize some more science and technology services. Please go to slide. Science and technology services that are enabled support and services for industries. So some basics like significance of my presentation is here I presenting that rationale is in AMP measurements and satellite data identified 124 non-attainment cities in 23 states and a national NCAP of MOFCC targeted also 20 to 30% air pollution reduction by 2024. And the scientific studies like source apportionment studies and 25-year air quality monitoring survey of CSIR IIT also revealed that the particulate pollution levels continually exceeding the national ambient air quality standards. So the theme is that the determination of priority pollutants of concern and establish the adequate scientific data and investigations to develop the control strategies that enable to abate air pollution at source and ambient environment. So the regulators emphasize mainly on obvious sources like industrial emissions, mines or like vehicular emissions of air pollution, and a limited focus on control of fugitive air emissions. So therefore, the action plans were found unviable and ending with a little success. So typically the two-way approach of control of air pollution is enforcement of stringent regulations and other one is the commencement of air purification device developments. So here, so I just highlighted the two case studies here. So earlier that we had done, it is an industrial city center where it is having the larger industries, almost more than 100 industries and more than 30 mines and other continuation vehicular trucks transportation activities. There we found that we have done the size distribution analysis using Moody. So here we can see the before rain and after rain, what is the distribution of the particle pollution in the ambient. So when the rain the before rain and the after rain, the difference that the coarse mode particles are disappeared. But this defines that the emissions coming from the combustion activities or the fugitives are from the road resuspension or other activities ground level having the more impact than the more impact at ground level. And another case study, if we see that is there are industrial shutdown due to the water unavailability. Some in the year 2011, 2012, and 2010 that we have seen that ground level, what is the NAMP data during these 3 years, subsequent years and comparison, we found that there is no much change in the at the ground level level. So still the particle pollution and air pollution levels are exceeding the standards. And when we have also seen the satellite data of these years over the 30 kilometers resolution, there in atmosphere level we found the difference. That is the mean the ground level activities or fugitive activities have the more impact on air, significant impact on the air pollution levels. So the action plans enforced by regulators started focusing on not only on control emissions of industries, but also local fugitive sources emissions and encouraging the control technologies. So the control technologies and device developments have been encouraged by government for improving the air quality of air by the public. So till now, this is the literature that is emphasizing about the technologies available for the ambient air purification in this. But in India, we see that very limited technologies are still means it is been taken up, and the technologies which are developed also it is at the field evaluation stage. So IITR has initiated to design and fabricate and evaluation of ambient and indoor air cleaning devices, and also testing of MSME air purification device technology efficiencies in different environment. These are the two technologies that is being started, initiated. We have we have done the numerical evaluations, and we are at the computational evaluations for fabricating these. So these are the two technologies that IIT are being developed. So other expert services are for EAA projects and rendered the services of baseline air pollution data and air quality modeling for EAA projects of NABET accredited consultancies, and providing technology support in preparation of effective detailed project report, pre-feasibility report, or environmental impact assessment and environmental management plan reports, and acquire of environmental clearance from the NYFCC and PCBs. And also giving the assistance during the post-environmental clearance and the scientific support to meet the environmental clearance compliance conditions. These are the other services like computational tools, technologies using for prediction and assessment of air pollution impact. Suppose like the regulatory models, air mode and call roads view. These are like regularly we are giving services through these modeling approaches for impact assessment of air pollution. And also IBM SPSS software and open air software. These are using for air quality database analysis and assessment for different conditions, environmental conditions or public conditions. So what is the impact of the air at different scales. And also ArcGIS and AutoCAD also we are using for geophysical mapping and geometry developments and all these, and health risk assessment also WHO AirQ+. Some of them are freely available, some are we have the license-based versions. And further, apart from giving services to industries, we're also conducting training programs under the skill development programs. Other things like the specific, some specific parameters, air pollution parameters like VOCs and organic, inorganic aerosol contamination in industries and urban environment, because of diversified sources and developments in nowadays. So specific pollutants, specific VOCs also required to be concentrate and to be evaluated and for the management of control of these pollutants. So we have developed the framework and research is being started. And we are pursuing this in industrial urban environment. We had initiated to establish the air quality facility under the DSR CRTDH. These are the devices, high-end and more focused, robust equipments. These we are using for at different industrial and R&D work, and training research, training students and scientists and engineers in various research institutions. So these are like dust analyzer, sound level meter, CO2 analyzer, VOC analyzer. These are very specific range. Very specific range, vast range this covers, and we do the monitoring using these devices, and also like ARI, NFRM samplers and thermo-environmental stack monitoring kit. And Engineer Khan already told some of these instruments. about that we are giving services through these instruments. And apart from other monitoring services, we are also giving training on conducting workshops with the support of DSR, CRTDH or DST, like the application of various statistical data, the statistical packages and software models to ascertain the air pollution and impact assessments. So thank you.
Thank you, Dr. Srikanth, and thank you, Dr. Khan, for highlighting CSIR IITR's capability on quality monitoring and the equipment's availability and amenities and facilities and the instrumentations, as well as covering the aspect of skill development. They are all very important sectors for connecting with the industries, because Srikanth also pointed out like various software tools. Currently, they are very like significantly contribute for industrial growth on Industry 4.0. So this way, we are going forward ahead how we can serve the industry, because since the IIT has started as occupational health, like Dr. E.R. Khan pointed out, when we started as occupational health of industries and industrial workers, now coming into the stage where the predictive approaches and AI, machine learning, and other the digital tools, how we can utilize them for environmental protection and services. So with that, now we are moving into another dimension of CSIR IITR. I welcome Dr. Rachna Kumar, senior scientist working at CSIR IITR Lucknow. And she's having experience of more than 14 years in R&D development on particularly chemistry aspects in developing CRMs, as well as developing technologies for very much relevant to industries. She's an experimental chemist and expertise in the area of material development for niche applications and reference material development to support industries. She has more than 50 publications, 4 international and national patents, 2 technology transfers, and 4 externally funded projects from DST and other agencies. Now I invite her for her talk. Over to you.
Thank you so much, Dr. Partha. So a very good morning to everyone. We have so far gone through the facilities or testing facilities available at IITR. I am a little bit taking you away from the topic, because if you look at the theme of CSIR iConnect, it is basically connecting the industry with the research. And if we talk about the industry, the first thing nowadays comes to our mind is the $5 trillion economy which India is targeting by 2025. And the big chunk of it can be only covered by the export boosting. So I thought to make to drag the attention of the industry people towards a very fundamental issue for the reference materials development, which is currently not being developed in India in a vast range or vast level for improving standards and analysis, which is very essential to boost exports by meeting regulatory standards. So if you look at the previous several years data, where the exports have been rejected from external, from the outer countries for various food products and like rice, wheat, several nutritions, and many more related to food and drugs. So if we look at further at the FDA data, which is available online for the last 10 years, we can see that India has a very consistent rejection of imports by USA, and the major contribution, or we can say the materials, which products which are being rejected, is from food and drugs. So there must be some very fundamental issue which we are not aware of, or we are somehow unintentionally we are neglecting it. So I have taken an example of one of the companies rejection data. What have they given actually? So it is basically, if you go through, you will find that it is targeting mostly the quality system or quality control being conducted in that company for the food testing. Although the consignment was bearing the certification from India, but as it reached their coast, it was not complying with their regulatory limits, and it was rejected. So this is a very big, actually, it cost a lot for the industry when quintals of consignments have gone over through one country to another, and it is rejected at their port. So basically, the things we need to have a bigger thought process and brainstorming on this point. Why is it happening even when we are so much well developed and equipped with the analytical facilities? So if we dig deeper, what we find is that the regulatory system in our country is quite stringent, and companies and testing laboratories comply with the quality system requirements. There is no flaws from any point of view, because the accreditation bodies are very strong in auditing and giving accreditation to the testing laboratories or the production companies who are manufacturing these products. Companies are very well aware of the quality control for production. They have the separate system for, or the department for, the quality control of their product. They follow the regulatory guidelines and are accredited in a regular interval. So still the imports are being rejected. So what could be the possible reason? And we have to go through and discuss about it. And the bad part is that India stands in top 3 nations for rejection. So we need to think, are we not doing correct measurements or analysis for international acceptance? Or in my opinion, I don't think so, because the regulatory bodies are so strong that there should not be any flaws in analyzing the or testing or certification of the products which we are doing, or for the export, which is the consignments are going on. So we might not comply their regulatory limits. This could be one of the reasons that several pesticides or heavy metals are banned in food products in external countries, and we are using it here. So there must be a reason that that this might be present, and we are testing it. It's not complying with the limits which they are looking at. So now I would like to drag your attention towards the real problem. The real problem could be the testing mechanism and the missing link we have to find, actually. So we are testing and giving certification. So all measurements are being done using the instruments. So all instruments need to be calibrated. So it has to be connected through this traceability chain. If you look at the pyramid of the traceability, you can see that we all have to calibrate our working standard. It has to be connected to secondary to a primary standard. So all measurement depends on instrument calibration and precision. Calibration requires certified reference materials or standards. We all are using CRMs in our laboratory to calibrate our equipments. About the CRM is that they have the expiry date, and the certified values are not valid beyond that period. So we have to be very careful in using CRMs, that we should not use it beyond the given date. Otherwise, the values are not valid in the certificate given. Also, the CRMs have to be stored and tested under specified conditions given in the certificate, and it is also the matrix based. So coming to the scenario of our country in India, only a few CRMs are being developed in our country. If you are aware about the reference materials being purchased in our institutes, testing laboratories or industries, it is mostly from the NIST USA, which is known as the standard reference material. And we mostly import them, because compared to NIST USA, which is manufacturing more than 2 lakhs of SRMs, which is CRM of USA, we are only around 10,000 of CRM developing in our country. So we are mostly importing all the CRMs to calibrate our equipments being used in testing and certification. So it costs huge to the companies and labs and makes us dependent on other countries for the supply of CRM. So CRM is really the backbone of the testing laboratory, but we are dependent for its supply to other countries. And also the drawback is that the CRMs are not available in the certain matrix type. As I talked previously, that certain pesticides which are banned in other countries, we want the CRM for that to test in our laboratory. Because it is banned or it is not allowed to use in other countries, they are not manufacturing these CRMs, or they are having for their own testing only. So they are not supplying to us. So it becomes as a like a handcuff that we are not able to test. So we go for the working standard or analytical standard, which takes you away from the true value which you are certifying, actually. So the CRMs are not available in certain matrix type in the range which we require. And also at the end, it costs both time and huge money. If you look at the down mycotoxin SRM, you can see that it costs around 1.5 lakhs without GST. And then the shipment time, you can see I took it yesterday. So it is ship on 30th August. So it is almost 1 month you have to wait when they will ship. And then means it will be like 2 months interval from ordering to getting your CRM. So it always delays your testing and accreditation and whatever, means the certification is really a problem because of these restrictions. So once we do not have our own CRMs development in our country, this restricts the comprehensive use of CRM because they are so precious. We don't use them whenever it is required. We keep them as a precious item and work with the working standard later on. So if you remember the pyramid, once you go away from the primary standard, you are adding more and more uncertainties in your true values. So it is essential to develop the required CRMs in our country to fill the gap, because we know what we need. So what we need, we should develop in our country. So looking again, the quality management system is everywhere in the testing laboratory and production companies. So all quality depends on the calibration process which we are using. So as I said, when we go away from this primary standard to working standard, we are adding actually the uncertainties in our measurement. And all this calibration process is connected to the CRMs of primary standard because it directly connects to your SI units. So once you are following this chart, you will be whatever you will be measuring, it will be accepted everywhere internationally. So look at this chart of uncertainty. Once you are having the national standard, which is the primary standard CRM, or you are going to the final product, your uncertainty is many orders higher. So if we are developing these SRMs in our country or CRMs in our country, we will be having facility to buy now and then, because it will be much cheaper than buying from outside, available whenever we want. So we can keep on checking the precision and accuracy of our equipment, whether it is required by the accreditation time or auditor or not. For our own purpose, whether we are how much near to the true value, we can keep checking our equipment's precision. So the most direct method of establishing metrological traceability to SI unit is through the calibration of our measurement system with CRM, which is very important to focus right now at the present time. So we need to develop CRM in our country in every sector, because we are working in every area. India is the agricultural country and is the leader in pharmaceuticals. We are testing and supporting several other countries. So it is very important for us to be self-dependent in calibration of the equipments which we are using for certification of these food, nutraceutical, pharmaceuticals, environment-related parameters. So one of the examples of development of CRM in India is this polystyrene film, which is developed for calibration of FTI instrument. This instrument is vastly used by the pharma industries because the drug they develop, they have to check the purity with this FTI instrument. So this card is holding a polystyrene film in the center, and it is used for calibration of FTIR. So if you look at the NIST SRM, which is usually bought by most of the pharma companies in India, it costs you around 1.5 or 1.05 lakhs per card, and it is valid for 3 years. So it means that every 3 years you have to buy it. And the lagging time was readily available, because there's a huge market of this polystyrene film in India. And you can see that when it was developed in India, it cost around 15,000 plus GST. So it is less than 20,000 per card. So you're saving huge amount of money going out of India. So this definitely adds into the economy, that even one card which is sold like 1,000 pieces every year, you are saving how much amount of money. So it complies very well with the pharma, European and Indian pharmacopoeia, whatever their basic requirement was there, it was fulfilling very well. So currently at IITR, what we are focusing, we are trying to start work and focus more and more on the testing which we are doing here to develop CRM for that. And this basically covers the fatty acid profile, pesticides, metals, and polyaromatic hydrocarbons. So fatty acids profile are required for edible oils for their certification of trans fats and other compositions of saturated, unsaturated fatty acids. So it is readily required by all the oil companies. And its CRM is available in 1 ml of ampules in a very volatile solvent. So it is not, means you are paying a lot and getting nothing from the outside. So it is essentially required to develop these CRMs. Similarly, we are testing pesticides in our department. So we need to develop all these CRMs in our own facility so that we can support us and other testing laboratories. Similarly, polyaromatic hydrocarbons. So these are the primary focus for us to go ahead and develop the CRM at CIR, at IITR as soon as possible. And long-term focus is to cover this food triangle for the composition and residues and adulterants in all the sectors of food, because India requires it. So we need to focus on the as much as possible the sections of this triangle. So this is the last slide, which we can clearly see that the standard improvement is directly connected to the guarantee, and it is the satisfaction of the customer which gives you the more and more business. So we need to support our industry by developing these CRMs, and IITR is now stepping very powerfully in this direction, and we need some industrial support if possible. If they can come to us in the from the very initial step, that will be wonderful, because it has a very huge market in India as CRM also, as well as promotion of your product. So there is a real need to connect the labs with the industry to become not only their problem solver, but also to boost the economy of India. With that, I thank you all for your attention. Thank you very much.
Thank you. Thank you, Dr. Rachna, for very valuable making very valuable points on how the research can enable the national economy and boosting our Indian capability in the global sector. And also that's very much you're covering various aspects, not only environment and also various other sector, food, pharma, and agriculture, pesticides. They are all very, very important for us to focus upon and develop capabilities in our country, so we can serve our industries in a much better way. Now I invite Dr. Manikam, Area Coordinator, Environmental Toxicology Division, to lead the session forward with interaction with the industries.
Thank you, Dr. Partha. Hello.
Any question from you, host?
Any comments? Anybody raised some issues?
I think something else. So you continue, sir, please.
Yeah. Hello. If everything is okay, let's. On.
Dr. Manikam, there
Yes,
is a
sir.
hand raised by host himself.
Sir, अच्छा नहीं here आप देखो.
Yeah, no host नहीं यहाँ नहीं host.
Dr. Dhirendra Singh.
Ritvik, Dr. Ritvik, I saw your hand raised. I think some mistakes are like we can go ahead. I'll talk to them in offline.
Sir, Dr. Tiwari, with your support, we are now moving into the industrial partners to showcase their interest and collaborative research with IITR. Some of them are, already they visited several times our institutes. They have presented their portfolio of work happening in their industries in various platforms. So we have around 5 industrial partners today, but 2 of them will speak and 3 more industrial friends will participate in the panel discussion. So if Dr. Can I just verify Dr. Chakradhar, he is there? Sir, Dr. Chakradhar, he was there in the morning?
He was there in the morning.
Me. Dr. Chinmay Nandi is there? Hello? He is there.
No, Chinmay Nandi move we call them, sir.
Yeah. Sir, Dr. Chinmay Nandi, sir, can you hear me?
Yeah, I can hear you. Can you hear us?
Sure. Very, very clearly, very loud and clear. So, just a moment, sir. If Dr. Chakradhar again, no. Sir, Dr. Chakradhar, can you verify whether you are available in the moment right now? No. Okay. Sir, so let's move on to here, Dr. Chinmay Nandi. Dr. Chinmay Nandi is our good friend, mentor, and seeking our collaborations in many fields. There was some little time lag. We need to work on certain interests. He put forward that IITR should help in this aspect. We are currently working out with our research planning division. Dr. Chinmay Nandi, formerly, obtained his formal degree in BSc Chemistry Honors, MSc also in Chemistry Organic from Organic Chemistry from North Bengal University, West Bengal. His PhD from IIT Bombay, Mumbai, of course, on synthetic heterocyclic chemistry, which is very important field. On those days, he did a synthetic heterocyclic chemistry. It's really amazing to note that. That's how IITs nurture young minds since beginning. So Dr. Chinmay Nandi is also done certain management course to reach the higher executive management positions, but specifically he learned certain specialized synthetic and process intensification at Cranfield University, UK, and also microreactor technologies from Erfeld Microtechnik, Germany. He has large number of patents, at least 3 US patents and 4 Indian patents. Dr. Nandi worked for an year in BRC and then joined NOSIL, which is a National Organic Chemical Industries Limited, NOSIL Corporation, who are the largest manufacturer of rubbers, and also they have R&D division, working on intensively to find alternatives, safer molecules, safer chemicals at Mumbai. So he has about 38 years of experience in industrial research, especially in development of chemical processes and lab scale commercialization, actively participates in several new process, new product development, taking them from R&D from industrial scale to see the commercialization potential. And his current area of interest is green, of course, as we talk this modern world, field of green chemistry, process intensification, catalytic process, and of course the new technology and new generation technologies for the current state of affairs globally being faced. His team aligns with the requirement in a sustainable, efficient process technology development manner. And Dr. Nandi visited at least 3 times in our institutes, and he is our mentor too in certain aspects. So, sir, truly, I'm extremely sorry. I must confess that we informed you in short notice. Please, over to you, sir. You share your thoughts. Thank you so much.
Thank you, Dr. Manickam. And also thank you all the CSR IITR director and all Dr. Partha for giving us all the inputs. The theme given is ecology, environment, earth, and ocean sciences and water. I think what I'll be presenting to a large extent connected with that. And so iConnect is a good platform to speak about it. And our effort is to reduce load on IITR on intervention of industrial safety and sustainability area. So our endeavor to do better to do production as well manufacturing as well as reduce pollution load. I'll just share my presentation. Is it visible?
Yes, sir. We can see your slide. Please go ahead, please.
Yeah. So as you see that this is basically a strategic approach towards industrial effluent treatment and sustainability. And basically, we always feel effluent treatment is costly. So our endeavor is to make effluent treatment more profit centric than cost centric, and this may well connect with E3OW concept. So as you see chemistry in our daily life, we get We can't live without it. We need medicines, food, clothing, and everywhere chemicals are used, and its manufacturing is essential part of life. So we have to manufacture it. But it has its downsides development. I'm not going very critical because I have given a limited time of 15 minutes. I'll try to finish as within that time. So it has a environmental pollutions, as Dr. Manikam has mentioned, the toxicology of pollutants, hazardous and persistent organic pollutants, which causes ecotoxicity and environmental pollution. And their load comes on monitoring of the end. So we are trying our best effort to reduce this pollution load through an innovative pathway. As we are seeing that there is an environmental pollution generated due to manufacturing of chemicals, generation of greenhouse gases. So a lot of environmental emissions happens, which causes this. There is a depletion of fossil fuel because we use large amount of fossil fuel in making generation of steam and using of electricity. And of course, depletion of clean water resources because industries, as such, water we are situation is becoming day by day difficult, and although industry uses only 5% of the total resources, but still there is a lot of pressure on water. So as you see in normally industrial effluent treatment plant, to reduce effluent load and reduce toxicity, there is a primary, secondary, and tertiary treatment. As you see, plant effluent is done, then raw effluent collection pit, and then homogenization, neutralization, then primary treatment, secondary treatment, and then tertiary treatment, and finally the is a activated sludge process. Mostly the bacteria biodegrades these molecules, and so toxic pollutants and all are reduced. And this is a kind of a bird's eye view of liquid effluent treatment plant, where multi-stage it is being treated. But it has its this conventional ETP. Most of the industries follow this pathway, but it has its demerits as well. As so changes in, because it happens, the changes in effluent composition in batch processes, decrease in bacterial concentration due to toxic influence, which are not easily biodegradable. High TDS causes less of oxygen and also affects bacterial growth. Changes in influent in multi-product plants, sudden deviation or shock loads from production processes, high non-biodegradable substances concentration, and high sludge production and disposal problem. So although there is a lot of effort done by these conventional methods, but these are the demerits which makes it less efficient. So as we go more on environmental sustainability, and more and more efforts are by all industries to meet the environmental sustainability. So we have to development that meets the needs of the present without compromising the ability of the future generation. So this is a concept. The sustainability in chemical industry, can be mitigated to a large extent, reduced by green chemistry and green engineering approaches. So we have to maintain social this triangle, environment also to be sustained, social domain to be sustained, as well as we have to make economic profit. So as there are 12 principles of green chemistry, I will not go into details. This is all available in the internet. But the one or two points, which is key points, I'll pick up. So essentially, green chemistry means reduction in waste, materials, hazard, risk, energy, and environmental impact and cost. So this is as we go on pollution prevention hierarchy in the industrial effluent. First thing is prevention and reduction, then recycling and reuse, and finally treatment and then disposal. So in this hierarchy, this green chemistry is a concept. As I explained, there are 12 principles. Out of that, this being done by using various techniques. These are called tools of green chemistry, like catalytic processes, greener solvents use of renewable feedstocks, waste minimization. There is an engineering concept called process intensification, energy efficient processes, effective separation processes, and safer reactions and reagents. With these tools, I'll just point out how we are approaching. One is the fundamental level through chemistry. So designing better chemistry in line with green chemistry, some few simple examples. this is one of the key principles of green chemistry is atom economy, because an atom is terrible things to waste, or rather it is called how many of the atoms of the reactant are incorporated into the final product and how many are wasted. So any atom lost is a not only loss of money, but also it has to be treated. So hence atom economy is very key in a fundamental level. So as you see in a chemistry, we learned in a basic, BSc days is a rearrangement reactions, addition reactions, substitution reaction, and elimination reactions. So our focus is, which is atom economic, which is not atom economic so much. So rearrangement additions, they are atom economic, and substitution elimination, they are not so atom economic. So in our design, we must improve the chemistry in such a way that it is use more of a addition and rearrangement and this kind of reactions where all atoms used in the raw material is get into the final product, and hence less atom is lost, or rather no atom is lost, and that is the most better way, then no toxicological impact on the environment. As you see in a simplest thing like phenol, which is traditionally even now made by aluminum chloride catalyst with benzene and to isopropyl benzene, and then further oxidation, and finally gives the phenol and acetone. However, new route where N2O is a toxic gas, which is treated directly with benzene and gives phenol. This is a new catalytic pathway, and this is being is being practiced in some companies, and this reduces and generates only innocuous nitrogen. So this fundamental level, all atoms are added directly, whereas other conventional route generates a lot of byproducts. Similarly, hydroquinone, which is a very important chemicals used in many industries. This is a conventional route made from aniline and is oxidized and then reduced, so it generates a lot of byproducts, which is needs disposal and may have a heavy metal problems. Whereas new route, which is a catalytic process where phenol is directly treated with hydrogen peroxide and gives only water as a byproduct, and gives hydroquinone and catechol, which co-product, and it is more efficient. It is being commercially practiced. Similarly, in esterification, this toxic carbon monoxide gas is being used by methanol and with a catalyst, and it converted to acetic acid and it's a methyl acetate. And similarly, MIBK is another industrial chemicals required in many areas, which is a multi-step process which creates a lot of byproducts, whereas there's a new route which generated directly acetone and giving this, hardly there is any byproduct, and that's make it more atom economic. Another industrial case like caprolactam, we use a basic requirement for nylon 6, and earlier conventional route is to create a lot of byproducts like ammonium sulfate, and this needs to be treated and disposed, whereas new route using a hydrogen peroxide and ammonia generates the first intermediate, which further again catalytically heated and gives the caprolactam, which hardly any byproduct like water. And that gives a more atomic economic process, and hence fundamental level in chemistry we can twitch, and there is no byproduct, and hence no major treatment cost or environmental emissions. Another very well-known chemical is a paracetamol, which you all take. It's normally made from parachloronitrobenzene, further hydrolysis and reduction and multi-step process. Whereas a new process developed by Malincrot, which is being industrially practiced using nitrobenzene through an intermediate with a catalyst and goes to paraminophenol and then acetylated to give this paracetamol. Hence, a lot of byproducts are saved, and this is a very efficient process economically as well as environmental point of view. So this is another approach. That's the chemistry aspect. I just highlighted few points. Another aspect is designing better process technology in line with green chemistry. As we understand in a chemical reactions, the kinetics of the process is to some extent hindered by heat transfer, mass transfer in a process, and hydrodynamics. So these constraints are removed by a new generation techniques and equipments. So this is directly intrinsic kinetics gives process and product, which gives a more selective and more efficient way it can be done. So how this is called process intensification approaches. They use a novel apparatus and techniques That is expected to bring dramatic improvements in manufacturing and decrease in number of equipment size, energy consumption, waste generation, leading to cheaper and sustainable technologies. This is a radical design approach, makes the production plant smaller, cheaper, and safer. The strategy is miniaturization, basically new generation reactors, which I'll highlight, but it also has an advantage in building the plant because 33% of the cost goes in civil and electrical instruments. And so major equipment only 33%, remaining thing is the cost. So these concepts, kinetics and thermodynamics constraints are overcome. And this is one can do multi-functionality in one system. So as this is a fundamental level, these systems or reactors, normal reactors has a very poor surface to volume ratio, and their new generation reactors are used, which is having high surface to volume ratio, which causes like micro reactors. I will come into that. Which causes the micro effects and improved molecular diffusivity, resulting in efficient mixing, high reaction rates, efficient heat transfer, and high energy dissipations. So it has a multiple benefits. This concept called process intensification. This is done in a much faster way. I'll narrate few examples. As we see here, chemistry's round bottom flask is can be using a microreactor. This is called microreactor as tool for synthetic chemists, the chemist round bottom flask of the 21st century. This looks like a small vessel. However, they are very efficient. Reaction happens in seconds. Hence, this is called, that's why the intensification happens. The product can be done very fast by changing the kind of design. Different kind of reaction can be done very easily, and they can be multiplied by adding more and more such tools. So this advantage is it gives a huge perfect mixing, good heat exchange, and small reaction volume for safety of the process. It has multiple advantages which I already narrated, especially safety and flexibility and efficiency. These are so hence time to market is much faster. So just some example is that this conventional technology of naphthalene, this nitration to form the nitro group, this is reaction tends to explode, temperature is kept minus 50 degree, and a lot of byproducts come. Whereas using this microreaction technology, reaction is controllable, temperature is room temperature, and only mononitro product is formed. Another cases is the benzyl chloride hydrolysis to benzaldehyde. Again, a conventional technology requires it has a difficulty in mixing. The low temperature is required, yield is limited. Whereas in using microreaction technology, fast diffusion happens. Temperature at higher temperature it can be done, hence energy efficient, and yield is high better. And reaction time is only 6 minutes, whereas other case reaction time is several hours. So that's process intensification helps in combining all this. So this is another. Normally reactors are made in a big tank and all agitation and all. These are the new generation reactors. It's called static mixer reactor, which is being offered by many companies, and both liquid gas can be mixed easily, and it happens in seconds and minutes, not in hours. Similarly, new generation reactors, that plate reactor, where again a mixing happens through a turbulent pathway, and reaction happens very efficient. Another type of reactor called spinning disk reactor, where efficient mixing happens due to spinning of the disk, and very good mixing happens, and reaction happens in a very fast order. So one simple example here, the narration is conventional plant for this nitration of organics. This productivity is 15 tons per hour, reaction inventory 13,000 liter, heat transfer poor, byproduct formation, safety. There is a issue of runaway reaction because of nitroaromatics. Nitration time is 18 hours, residence time 30 hours per batch, and complexity is there. Whereas this process using static mixer reactor, only reaction inventory is 0.2 liter, it's 200 ml, and heat transfer is very good. Byproduct is virtually eliminated. There is absolutely no issue of safety, no runaway. And nitration time is 0.25 seconds versus 18 hours. Residence time is 1 minute. And this kind of thing helps not only safety and very selective, better selectivity, which helps in waste data waste generation and hence less treatment environmental emission. Another thing which as I said, reduction of pollution, we apply this chemistry aspect, then engineering aspect, as I narrated already, and there is a last aspect, which is applying 3R, reduce, reuse, and recycle approach in line with green chemistry. So we employ a lot of innovative separation techniques to recover valuable chemicals, including water, and reuse and recycle wherever possible. So among these separation techniques is innovative ion exchange technology for treatment of aqueous effluent streams, developing greener processes through recovery and reuse of valuable products, application of adsorption technologies using specialized granular carbon, and this adsorbent we can recover back and reuse that. And also a lot of things getting popular using membrane technology, again for isolation of chemicals and purify water. And of course, there is a process integration and development of continuous process or combining the process, which helps in more efficient way of carrying out the reaction. So multi-stage process can be combined, and they can, by that way, we can get more efficiency, recover and recycle valuable chemicals and product. We actually, all these areas we applied in our industry. In fact, our company was in 2017 got Acharya PC Ray Award for development of green technology of one of the product, and which is being practiced. So regarding ion exchange, we know all this a resin having a functionality. So this ion exchange resin having any cationic, anionic species or even adsorption or chelating, it can capture all those so-called pollutants, and hence we can capture them from a large pool of things. When it is a very small amount, it's very difficult to employ a normal conventional chemical technology. And these things, they absorb this pollutant, and we can capture them and then either recover them and either reuse or destroy them efficiently. So this is a kind of a resin kind of column, and we did there are a lot of fundamental areas, and we did employ, and at our industry we are practicing number of places we are employed this technology. So so this is the one example I just highlighted. So we have some catalyst of sulfonic acid, aromatic sulfonic acid or aromatic carboxylic acid, which are non-biodegradable, and their loss of value, they are very costly components and high treatment cost. So we employed ion exchange resin technology, and we recovered reduced COD reduction by 98% from aqueous effluent, and also 98% of this species is recovered and recycled. Another aspect is using granular carbon. Is a specific type of carbon has a thing. We look at more of a mesoporous pores are higher. So as you know, it has a microporous, mesoporous, and macroporous, and depends on the source of the carbon from which it is made. And this mesoporous type of carbon becoming more popular. So we use some of them, specific ones, which are coal-based and peat-based, and which efficiently adsorbs a lot of valuable raw materials. And we did employ an extraction in kind of absorption of the aminic compounds, which is very difficult by chemical techniques, and it kind of absorb them, and we dissolve them and reuse that. So that helps us in development of this. So in essentially employing these three aspects: fundamental chemistry change, technology change, as well as 3R approach, we get a sustainability through green chemistry. Again, we have a triangle. So that gives us the opportunity to less energy and less raw material consumption, less emission of waste, safer process, smaller plants, and lower cost. So all things are balanced, and this type of concepts are becoming more popular, and we are employing immensely in our testing, and day by day more and more across the globe these efforts are being done. So as you see, one just picture, this one is the tabletop model where high pressure hydrogenation is being done, and 100 metric ton is made per year by using a tabletop, because the reactions are very fast in a few seconds. So all the safety and building a big plant reduces. So our idea is to present to future is to from a cathedral type of big kind of industry, miniaturized plants as you see, and hence I mean employing this, we can get a greener perspective and can reduce the toxic aspects or all POPs and this other chemicals which affects the earth, nature, water, earth, and gases. So that will help. So as it is narrating, we do not inherit the earth from our ancestors. We borrow it from our children. They will borrow. Thank you.
Oh, great, sir. Wonderful. Sir, as you have heard since morning, this E3OW theme, that is Earth, Ecology, Environment, Ocean, Water, we want to see less chemicals in the environment, the chemicals with reduced toxicity. Truly an amazing example with case studies you presented, how following the success, sustainability and green chemistry route, with case studies you have explained, like even starting from paracetamol, which is a common drug, how you circumvent to achieve a molecule which can produce less and less byproducts or toxicants. Wonderful case study, sir, and definitely your lecture, presented a theme which is very minimum waste generation possible. Wonderful, sir, to have you. I am sorry, as I said, very short notice you could join. We are immensely thankful that you have connected through this truly research connecting the industry. We look forward to more work joining hand with you, that we will soon send letters so that we initiate those work you are discussing with us. I'm thankful to you again for sharing these advantages of microreactor technologies, separation technologies for valuable chemical harvesting. So thank you so much, sir. And now we move to Dr. Chakradhar. Yeah. Thank you, Dr. Chinmoy. Nandi.
Yeah, can I just help to switch off my thing? There is some problem at my end.
या आप अनशेयर कर दीजिए सर, स्क्रीन को अनशेयर कर दीजिए. नीचे स्क्रीन बटन होगा ना,
Just unshare.
Sure. It becomes small.
Dr. Chakradhar, can you share your slides so it will automatically?
Yeah, it will override that.
Oh, great, sir. Great, sir. Thank you. You heard what we discussed? Of course. Yeah. Thank you. Dr. Chakradhar?
Yes. Yeah, good afternoon, everybody.
Thank you, sir. Thank you, sir. Can we see you? Can you switch on?
Yeah. Basically, I was traveling, in fact, I told you.
Sure, sir.
Because I was on some official travel
Yeah.
from Hyderabad. But however, I thought when you called me, definitely as a oldest colleague since last 3-4 decades, I never said no. So basically, I was having a presentation, but right now I don't have the infrastructure to make the presentation, but I'll speak on the topic which you are allotted to me. Definitely. The requirement of impact assessment. Basically, you see the talk which you have allotted is one of the, what I can say, richest topic in the country today. When we talk about sustainability, when we talk about the carrying capacity, whatever else may be, any developmental project which is setting up in the country definitely required an impact assessment studies to identify what type of impacts, environmental impacts, process impacts, and all other socio-environmental impacts. To identify that, this EIA studies is almost way back in EPA guidelines from Ministry of Environment Forest. Most of your institute also very rich in carrying out impact assessments. We have certain institutions like CSIR, NEERI, many institutions have come up to provide such services. Along with, there are plenty of consultants available with accredited organizations who are undertaking such studies. Basically, when we talk about the requirement of impact assessment, you see today we have multi-set of sectors of industries. If you see the ministry as well as NABAT websites, you have around 40 to 45 sectors of industries available in the country. They are broadly divided any activity into these 40 to 45 sectors. So you can imagine the variety and dynamism of variety of topics, variety of subjects, variety of products we are manufacturing. And each process, product, unit operations, unit processes, whatever we call it as, definitely going to generate some sort of environmental impact. So that's where the quantification as well as qualitative as well as quantitative estimation of what type of environmental damages, what type of social impacts, what we are all anticipating is inbuilt in this impact assessment studies. Today, it's a huge process of various, there is a huge methodology day by day since last 3 to 4 decades. The impact assessment studies were pumped up from the initial stages to today. If you see, almost with manual activities to online activities, entire digitization, remote sensing, as well as GIS techniques involved in estimating the quantification of impacts is one of the richest data-based impact assessment studies were available today. Whatever you see, pharma industry, you talk about distilleries, you talk about thermal power plants, you talk about, there is a huge process available in our country, and most of the colleagues are well aware of the procedures. Now, my main intention of briefing, particularly the components, the variety of components of EIA, particularly air pollution, water pollution, solid and hazardous waste activities, socioeconomics, ecology and biodiversity, hydrogeology, geology, air quality, land use, land cover activities, risk and hazardous assessment, soil conservation, noise and vibration. These are all the areas where if you really think about 3 to 4 decades, we were not, except air to water acts, there were not much. But over a period of time, as the activities, unit processes, unit operations are very variable, the quantitative methods also developed. So whatever I read, almost 12 areas today, people has to be expert in these areas and conduct a thorough study to see whatever the baseline studies, what we call it as, then basically predictions, how exactly what we are expecting in future once, because there are methodologies available, softwares are available to estimate the quantitative impacts. Today, what is the present scenario? That's the basic idea behind environmental impact assessment is before, during, and post. So these are the 3 different areas it will cover up when you do a impact assessment. So before, what is the status? During operations, what type of impacts, different impacts, and the post project operations. So these 3 will be covered in such a way, all the impacts, whatever identified, as I read out, around 12 areas, ultimately providing environmental impact management plans, and the disasters, if at all any risk-oriented, particularly petrochemical products, ONGC activities, oil and natural gas activities, majority of the pharma industries, huge risk and hazard activities are involved. So disaster management plan, emergency preparedness plans, as well as environmental management plans. So these are all the variety of studies inbuilt in impact assessment, which ultimately decision makers can take the call whether this particular development activity will survive in a longer basis or in a shorter run. So the environmental impact assessment study, one of the richest, as I called, database studies, wherein multidimensional areas, multidimensional experts are needed along with a coordinator of the project, and ultimately deliver for the clients, whoever is carrying out such studies. So variety of methodologies, you have plenty of data available, websites are available, what are the methodologies, what type of, how the process. Fundamentally, when you want to deliver a EIA studies, it starts with the Form 1, that is terms of reference will be given by the regulatory agencies, either it is state government or Ministry of Environment, followed by baseline studies and followed by a public hearing. Today, the public hearing, public consultation. These are the two areas where fundamentally the data has to be projected to the people surrounding the project developmental area so that their opinions will be taken into account and inbuilt in the final impact assessment report. So then this entire cumulative impact assessment report will be projected to the regulatory committees so that they will really analyze tooth to nail so that you see that what type of social impacts are there, what type of process impacts, what type of environmental impacts are available. Then ultimately, it's become a biggest tool for the clearances to provide and a developmental project to move on. So today, this is one of the most important Ministry of Environment and Forest process which is adopted, and day to day, every day, even yesterday, there was a meeting in Hyderabad by Ministry of Environment as well as NABARD for the modernization, updations, versions. This is the fourth version we are getting different updations. So every updation requires a new study, particularly vibration study, GIS studies, remote sensing, geographical studies. So the olden days we used to have air, water, land and all conventional studies. But today every report covers more than 12 functional area experts so that a comprehensive document can be prepared. So I thought I just gave a brief of impact assessment methodology as well as what is the present scenario in the country, particularly in the Ministry of Environment or state pollution control boards. So this is what I just thought of sharing with you people. Thanks, Manikam, for calling me. However, unfortunately, I am on a travel to official travel, but I felt I cannot say no to you. Thanks for inviting me, Manik, Dr. Manik. Thank you.
Sir, indeed, thank you so much, sir. These are, even though you spoke briefly, these are valuable thoughts, both required at the industrial research and national level. As you said very rightly, how impact EIA assessments are required for the regulatory purpose at all, regulatory purpose and all. As our team director in the morning, Dr. VM Tiwari told that large number of trust is required for anthropogenic activities mediated waste. So I am sure you have a vast expertise that, more than 3 decades you work. After working, of course, in the National Environmental Engineering Research Institute, you are a family member of CSIR. That's why we take certain liberties in inviting you with short notice. But indeed, sir, we are privileged to have you have your thoughts in this Connect event. But of course, we will continue to interact with you and get your inputs whenever we take specific exercise. Thank you so much,
Thanks,
sir.
sir.
Okay, sir.
Thanks a lot, sir. Thanks to everybody. Thanks, sir.
Thank you, sir. Have a nice day. Thank you so much. So with that, two major industrial partners who shared their thought, we come back and then in panel again we will have more industry persons to give their views and stakeholder kind of partnership we will discuss. But before we move on to the panel discussion with our colleagues and industrial friends, the final presentation from our side is from our own friend Dr. Partha. Dr. Parthasarathy needs no introduction among us and to the even national participants. He heads computational biology division with the toxicoinformatics and industrial research as a major thrust in his research endeavor. He has large number of students working on environmental issues by adapting to ML and AI tools other than regular bioinformatic and computational tools. To this event, he particularly want to emphasize and share the success stories from CRTDH, which is a DSIR supported hub, and also little bit he may touch upon BioRack, BioNest also. So without any delay, Dr. Partha is invited to share his view.
Thank you so much, sir, for very briefly introducing our topic of today's talk. So, very good afternoon, everyone. And today I'm briefly going to cover about our initiative of one of the important ecosystem development in the environmental monitoring and intervention sector. So in 2019, we have established this environmental monitoring and intervention sector at CSIR, Indian Institute of Toxicology Research. Since from the inception, this institute is contributing to the environmental issues in this country. So our next. So our institute, this hub is mainly focusing on 4 major verticals. Developing technologies for water treatment, effluent treatment, air pollution abatement, and also developing a capability or trained pool in this sector to generate the human resource to work in industries as well as R&D institutes, R&D aspects of this of the environmental monitoring sector. So we are focusing on drinking water disinfection, water quality assessment technologies, and technologies to treatment of industrial effluents from various industries, including pulp and paper industries. And recently, we are developing these predictive approaches of build models of source apportionments for air quality as well as pollution abatements. I will cover it up in detail of various aspects. And in a nutshell, our DSIR, IITR, CRDDS, with working with a mission on technology-oriented support and efforts-oriented services. So we are developing technologies on one hand, on the other hand, we are providing the services to the various industries in need. So we are working on product development, process development, and serving MSMEs in the environmental safety and sustainability. So as I said, like our center, we inaugurated in 2019 in May, but we have more than 50 years of experience in working in this sector. So morning, our colleagues have highlighted about various sophisticated instrumentations available. Apart from that, we have 2 different campuses, like main campus in CSIR IITR and the Geru campus. We have enormous amount of capability and capacity to set up the pilot scale also for various industrial needs. So since inception of GLP and NABL, we have NABL certified for air quality assessment, food products, and various aspects of groundwater, water residue, effluent treatment since 2000. And recently in 2014, we have a GLP facility. We are one of the first in the government, and now we have several GLP facility available in the government, as well as totally 52 GLP centers are available in India. So we are one of the very important, play a major role in bringing this GLP into the country. So we are providing services for the industries of various product and process development, and also testing their toxicological need of their sectors. So far, during the past 3 years, we have served 26 MSMEs in the sector, and 2 residents also we incubated at our center, and they graduated. 2 patents has been filed, and some more in pipeline. More than 14 workshops and 3 international conferences conducted to disseminate our knowledge into this society. And also more than 370 manpowers, like now more than 500 manpowers got trained of various workshops, seminars, and conferences for skill development. So to highlight our achievement of this sector, of this center, we have commercial models, like that's technology developed by CSIR IITR. That commercial models of continuous water treatment technologies developed by the institute are available for non-exclusive licenses. They are very, very scientifically and technologically sound technologies with reducing minimizing the water wastages. That's one of the advantage of these technologies. And we also developed a waste to wealth approach by taking the lignin or like coming from the pulp and paper industry waste or biorefinery, biofuel industry waste, taking them and converting into a value-added products. Our research scholars, like they are putting a lot of efforts to develop this value-added product from industrial waste. And few other commercial models of water disinfectant technologies developed by the institutes also available with us, and a few other gel-based filters and removal of salinity and loading with pesticides and removing the fluoride, nitrates are present in natural waters. So we are working on various aspects, and those prototypes also available with us in our institute. Next.
Next.
Yeah. On the effluent treatment sector, one of our scientists, he developed here 2,000-liter bioreactors, and that is deployed in the on-site of the pulp and paper industry, and that is in the testing mode, and that show very, really promising results. And our scientists also working on the waste to wealth approach, the biochars from the sewage and pulp paper industry, and develop the treatment technologies of textile and industrial effluent treatment. So we are working closely with various sectors like leather industries in the Unnao and Kanpur region, as well as dye textile industry. The dyes treatment also we are working on it to reduce the environmental burden, as well as supporting the industries for their sustainability. Bioremediation technology, Dr. Manikam Morning pointed out, like that technology also tested in the land scale level, supported by some of the DBT programs. Now we are taking to much larger scale through our DSIR CRTDH hub. We have few membrane development models membrane also in pipeline, technologies also pipeline, and we are working more towards like bioeconomical approach, very cheap and affordable and efficient of treating this heavy metal contaminated water. Air monitoring, pollution abatement, morning engineer E.H. Khan and as well as Dr. B. Srikanth has covered it up, various industries we are serving, and we served also continuously. And one of the patents also we filed for indoor air quality and as well as outdoor air quality assessment device, which has combined with monitoring and management using artificial intelligence machine learning tools of very on-site monitoring as well as making the necessary management in the effective treatment of air quality in the particular places. This is the portfolio we have right now, and I'll cover it up each one very, very quickly. Some of the technologies we developed is, as I mentioned, large-scale pilot plant and bioremediation technologies and water treatment technologies and portable water analysis kit. Currently, Dr. Rachna also is developing into advancing this technology into various affordable applications. There are prototypes also available with us, like biochar technology, air quality monitoring devices, and lignin-based hydrogels, and green processors like microbial-based immobilization technology for treating effluent treatment. So some of the companies on board, they come to us and they are developing technologies. We are testing them and guiding them for how to improve upon or how to value add to the technologies. And few companies work with us on site, and they graduated with the more advanced technologies in the water treatment. So we go regularly visit these places in industrial sector and collect the samples, and that's where it's got into this technology development of pilot plant as a bioreactor that's installed in Yash paper mill, and further testing is also under process. So these technologies, not only the pulp and paper industries, we are moving with this microbial consortium developed by CSIR IITR for textile industries, dairy industries, leather industries, and various community and sewage effluent treatment. As I said, again, waste to wealth approach, our group like Dr. Abhay Raj, Dr. Preeti, they are working on these technologies of converting this biochar and moving into treatment of various effluents coming from the industry sector. And we got really very stunning results of using this technologies developed within CSIR Indian Institute of Toxicology Research, as well as and Dr. Manikam sir morning pointed out, they are particularly on the pesticide our microbial consortia developed by in our CSIR IITR is effective in treating the pesticides found in contaminated lands. Air pollution monitoring is another major sector we are currently serving in the DSIR hub, and we served almost in the North India level of pan-India level. Morning, he's listed many industries and many MSMEs. Pan-India level, we are currently working of providing these services. And we are also moving ahead with various technology development. Dr. Srikanth morning mentioned about fabrication, evaluation, ambient and indoor cleaning devices. So this is the outcome of one of our FTT, fast track translation project established by CSIR. So on 2G ethanol. So lignin considered as a waste from biorefinery. We have taken this lignin and converted to value-added material that used for treating as a hydrogel that can have a higher water absorption capacity as well as absorbing the contaminants, or we can tune them into microwave loaded rich polymer, so that can effective in treating various wide range of effluents. So this patents also filed with us, and air monitoring devices also, this patents also filed in through our hub. And skill developments, we have because training the trainer is very, very important. I think during our panel discussion, Dr. VP Sharma, Dr. Nasreen will cover this aspect of skill development, and we have several courses running continuously throughout the year to skilling these resources from academia, industries, to harness their capability and fine tune their skill sets. And we also do a lot of outreaches. And as I said, we are also doing monitoring services as a societal activity for monitoring Lucknow for more than 22 years. And also during COVID time, we also serve, our team, DSIR Hub, served this community by producing these sanitizers and serving to the essential workers in the district of Lucknow. So we are closely working with various industries and targeting different sectors, and food, agro products, pulp industries, leather industries, agrochemical. So here, not only CSIR technologies, we are also currently depends on the various requirement of the industries. We are connecting with various CSIR all over the country, where they have so much technologies, membrane-based technologies available. NGRI developed some technologies, CSMCRI have some technologies, and Humphrey Bopal, and so many institutes, NCL, IICT. So these technologies also, basket of technologies are available. Depends on the requirements of the industries. We are connecting them and going to serve with the industries for the essential requirements to protect our environment and as industrial safety and sustainability. So with that, the way forward for the center, we are creating state-of-the-art analytical facility as well as various lab scale pilot plant also we can develop at the on-site. And we are serving MSMEs, and we are going to have more MSMEs in and around Lucknow, as well as we want to expand not only in UP, for other states of the country, and developing various personals with the various skill development and workshop and harness their skill sets. And this is our team. They are playing a major role for the success of this center. So they are the persons really doing the work. I just presented on behalf of them. And thank you so much. And also I would like to thank DSIR for this wonderful support to establish center at CSIR ITR. Thank you so much.
Very good. Thank you. Thank you, Dr. Partha. Very comprehensively yet effectively shared the roles played by different partners, be it research industries or colleagues from IITR. You have very rightly showcased the strengths of CRTDH and their, of course, the role CRTDH is providing to the immediate partners available in certain domains like air pollution monitoring, remediation, wastewater treatment, of course, other technological development, including energy sector like ethanol development, 2G ethanol. Very good. So with that highlight from Dr. Parthasarathi, we now can move to the panel discussion.
Yes. Thank you so much. Yes,
it's already.
So, yeah,
12:40.
very sorry for the delay and taking all of your time at Saturday and weekend. And without further delay, I'll invite you, the speakers as well as panel members, for the discussion session. And now I invite Dr.
Tell how it goes. Like, so for example, even during their talk, can industrialists come in, or total something like 20 minutes? I see.
Yeah. So in another 20 minutes, we'll discuss about. First, we'll have very pertaining questions, like we have expert members are available from scientists and academia, and as well as the industries. So we are going to ask some kind of what will be the way forward. That's our kind of the goal for the entire session. So in this session, I will invite Dr. Dr. Kisku sir first. He is the head of our environmental monitoring division. He has a rich experience in the work of environmental monitoring for past 30 years and working very closely with the industries. So I request him with a question like, since he has a lot of experience, I would like to get his opinion on what industry is looking for our expertise from our scientists or this kind of institution, and what will be the future directions we need to focus upon this particular sector. Over to you, sir.
Yeah, thank you, Dr. Parthasarathi. Myself, you know, Dr. G62 from Air Pollution Monitoring Lab, and already Dr. Shrikant and Khansap, Engineer Khansap have given the brief details about the lab and our potential of that. So, over the years, 30 years I am working in this field. So based on this, my experience, some of the things what I would like to raise the points in this forum. Like success of Swachh Bharat, whatever we have been planning, that totally it depends on the how we are handling the situation of byproduct, solid waste byproduct and other liquid waste byproduct from the thousands and thousands of industries, and even in the municipal corporation. So this one is that depends on the handling of the solid waste. Now in city you can see everywhere the pollution is increasing. Then why every time we are doing monitoring, but even then it is increasing? Why? And you see some of the things that which we measure, that that is very fine. We monitor this thing, we recommend something, but some of the things like old vehicles, e-waste, solid waste problem, still it is problem. And I do hope this in the coming year, just like air pollution, water pollution, another pollution is coming, that is e-waste and phase out of old vehicles. And many of the, even then if you go for Lucknow inside road, many of lanes are in the parked by the old vehicle, and there is no scrap sector. And I think it's a major problem, not in this Lucknow city. It's a very basic problem for the every metropolitan city. And there should be at least minimum 1, 2, 3 scrap center for this old vehicles also. Then what we did, we first generally just like we polluted the air, then we refine the air. I do hope this one, it is not the good approach. Good approach should be the air pollution or water pollution must be controlled at the source itself, not after discharge of pollutant in the atmosphere other than control. Just like he telling that we have India, we have the Varvara, we have the waste treatment plant, but that is around how much capacity? 350 ml capacity. And Lucknow is producing around 800 to 900 million liter wastewater. So there is shortfall of this one. So basic is that one, that you suppose if you have the society, then you have to treat your wastewater at the source itself. And then no modern housing society should be allowed to come up with this without the basic problems, how to they dispose their solid waste, how to handle their waste, liquid waste. Otherwise, no society should be given the permission from the municipal program. Then see this thing, and then the risk assessment, risk management. So risk assessment and risk management we generally do in the lab itself, but what happened now? Risk assessment, risk management, it is applicable to everywhere. So risk assessment, how do we do the risk assessment? These 3 steps are there. If any problem is there, you first identify what are the problems in the city. Then you measure the city, what is the problem, how much is the magnitude of that problem. Then after identifying the problem, you measure the problem, then what are the options? And from that one, not one A, B, C, D, just like cricket team, they have the plan A, plan B teams, the plan B, A planning. So according to that one, you have to have alternative plans, and which plan should be accommodated and which plan should be taken over as a. Then what we did, we most of the in Indian market there are many rules are there are many laws are there, and we formulated 20 years back and 50 years back also we have taken the plan. We have subsequent rules and regulations, even the knowledge also. But what we are lacking the enforcement. So to control that one, you must have to, a government must have to control that thing. Then another thing what I have seen that air pollution, water pollution is a bigger problem because every individual is contributing the pollution problem. So when it is coming to the control or abatement of pollution control, then only academician, professor and scientists are engaged to control that one. No, I don't think that this is a right way. Since it is a individual and from the every household, everybody is driving the car or driving the scooter. So each individual is responsible to control that way. So this air pollution, water should be controlled, should be done collectively, not with the only government agencies or with the scientists or with the academician professor will solve the problem. It is impossible for that one. So environmental pollution must be collectively controlled by participation of every individual. Then another thing we did not calculate, although it is in the books, in the environmental science and engineering books, you will find what is the cost of economic cost of this environmental pollution. We don't have any estimation like Lucknow, how much we are losing for the because of the air pollution, how much percentage in the suffering from asthma, how much percentage from cardiology, how much in the similarly, how much in the for because of water pollution, how much in the we are causing the economic loss. Just like in the Ganga phase out, Ganga phase 1, phase 2, how much we waste the resources? At least 20,000 crore, 16,000 crore. So this way, we don't have any economics of that one. Each and every project because of environmental pollution, how much losing, that economics should be calculated. So this, if once we calculated the economics of that, Jamuna, we are losing this one, Gomti for this one, each city is losing for because of health ground. So that to be, if it is calculated, then only people will come to know, oh my God, we are losing the 50,000 crores or 1 lakh crores of money from over India. So these economic cost should be calculated, estimated for every district or every river or like project, so that it becomes too sensitive then when we digitalize this information. With this, I do hope that now, although the very good speakers are there and everybody cover very nicely and experts are there, only thing I told you, effluent treatment plant is there, but what lack of the what gap of the 800 million liter waste, and we have the 400 million liters. So 400 only are going to the river. This gap, the treatment technology is there, everything is there, knowledge is there, experts are there, every professor, scientists are there, but we lack to enforce the execution of the rules and regulations in the field. Thank you so much.
Yeah. Thank you, sir, for briefly covering your point. So yeah, you touched upon very loopholes and where how I can fill in for having a bright future ahead for our nation, not only our nation in the globe. And now I invite our industrial members, Dr. Dhirendra Singh. Dhirendra Singh and Alok Gupta, Ishar, you're online.
Yeah, hello, sir.
Yeah, I'm here, sir.
Yeah, thanks for joining within the short notice. And it's like very general question to you. Like we are currently interacting with you all like on various issues, how we can collaborate together and taking some of the technology forward. And first, Dhirendra Singh, Dr. Dhirendra Singh, can you quickly talk about your company and what kind of expectation from this kind of R&D institute to build upon and strengthen up your need in this environmental sector?
Right. So, sir, I currently, Delhi-based. We are into
simulation modeling, and IoT-based monitoring device development. So currently in today's session, there was a lot of intellectual thoughts, but once we do the monitoring, there is no input of the time. So air quality in Lucknow, morning 7 a.m. If you are doing the monitoring, and the same place if you are doing the monitoring at evening 7 p.m., you will have a different reading with the same devices. So once we take the use of some latest technologies, maybe intelligent devices which are IoT based devices. So just quickly I will show you one of the device which is my screen is visible, sir.
Yes, we can see. Yes, we can see the image. Yes, please go on.
Yeah,
Display.
yeah. So when we talk about the air pollution, I mean we will be talking about removal of I'm talking about the indoor we are removing particulate matters and some VOC, SOx, NOx, and everything. And so there are no technologies which are available. I mean, everybody claims like we have better technology. I mean, if you talk about nanotechnology based filtration system, fiber filters, bipolar ionization, and further to it, the cheaper technology which is UVC. So everybody is claiming about 99%, 89%. So as a user, which technology, I mean, further, as an institute like IITR, I mean, there are, lot of devices, scientists, research experience available. So once we, create a particular due diligence, for example, we will be creating, devices virtually and understanding their behavior in different with different input parameters. Not only we are taking a time as the input parameters, then we will be analyzing with the help of simulation, IoTs, and we will be able taking right decisions. So I mean, if environmental situation you consider, I mean, if you are exposed to air pollution for 2 minutes, and if you are exposed to air pollution for 2 hours every day, and what will be the impact on your health? There is, no innovation, and I mean, very limited innovations which is available. So these type of, concept devices, which is very very low cost devices, and you can have this. Type of data, it can be further calibrated and it can be indigenized, and these technologies can be further developed in India. It can not only solve the problem of the costing, but also it will give better confidence to the things. So with the help of expertise, with the validation, data acquisition, data in terms of numbers, data in terms of physics or chemistry or biology, the proper analysis, we can, able to help the end consumer, maybe the NTPC or maybe the B2C consumer, which is suffering for these particular air pollution, and we can develop, we can solve real-time problems with many other scenarios, sir. So with this, I'll just complete my talks. Thank you so much for giving the opportunity.
Thank you so much, Dr. Alok Gupta. Now over to Dr. Dhirendra Singh.
Yeah. Sir, am I audible?
Yes, yes. Very well.
Yes, sir. Thank you very much. And this is what I feel the initiative of CSIR is very much needed. We are going back to our Vedic roots. So what I mean to say is today CSIR institutions like CSIR, they are our gurukuls. So in Vedic time also, the societal problems and governing everything. So they were derived from basically those schools. So what my understanding is like, to come up with industrial and research collaboration is basically, with this collaboration, one can take advantages of the capabilities and capacity on the industrial side as well as on the research side. So that is pretty much needed. And if you allow me to to share 2-3 slides,
Right.
I think I would be much
Please go ahead quickly. Thank you.
Yeah. So I'll straight away go to our credentials. Like we are working with in air pollutions in so many sectors, and we were fortunate enough that society has recognized and give us 2-3 awards. And these are our clients: Qatar Petroleum, Qatar Energy, Dubai Municipality, and few more research institutions where we are delivering our services. And the one good news which I feel is we are on a verge of the industrial growth. So we are the sixth largest economy. And last week there's an news where some reports have highlighted that there is 0% probability of getting recession. So it's a good news, and we must capitalize this industrial growth with the research as well. So right now, where we have limitation as far as the industrial toxicology is concerned on the academics, or sorry, on the industrial side, is one, we have the weak infrastructures for research and industries, because we are still growing and making a mark in the global scenario. So this is one of the key area where we are lagging. That is where we look up to the institutions like CSIR. They can provide us the infrastructure or for research. Lack of skilled manpower and awareness to compete industries at the international level. And this is pretty much linked with our agenda as well. Like, we are not aware of how this sustainability would play a role in our growth, in industrial growth. So that is where we want you to step in and guide us in way forward. So, and one of the article which I find out, like, the corporate sustainable reporting, which is now a mandatory at the global level, where our MSMEs are struggling. So this is one of the key areas which includes all the air, water, whatever we are talking about, the various aspects of sustainable environment. So one such example is like UP forest government was not able to sell their timber in the market unless they are not FSC certified. So FSC is Forest Steward Council, which is an European body which approves the sale of timber globally. So these sort of compliances and all those things which which we need to be aware of, and this is one of the key area where we are looking to the CSIR. So this also gives an industry a brand reputation and public trust. As in Dr. Nandi presentation, I saw where just below the logo it was written the ethics of excellence. So these sort of things, if that Mafatlal name came to me, I straight away recognize it's an ethics of excellence. So this sort of impression with each and individual industry, that is very much needed. So this already, like, this is one of the key aspect now. This is NGT, something comes up, they ban the construction, these sort of problems. So we need the intervention of your expert group where this kind of problem would not come up. So and where we as an airshed can help us out, because we have two patented technology available with us for high volume PM 2.5 bioaerosols and air pollution compliances. We can give we are very much capable of industrial pollution remediation, where now we are providing technologies to Qatar Petroleum and Dubai Municipality as well. And we are very much also capable of fabricating and designing the air pollution control devices. Even with your help, we can also customize, develop the customized and retrofit solutions for the pollution control. So that is where, sir, we have a strength of 65 members with us who are working in different sectors, and we would also like to collaborate with CSIR and be a part of this industrial growth journey, which is very much essential for the development of nation.
Yeah, thank you so much, Dr. Dhiren Singh, and thanks for covering all the points. And very well, we are taking your concerns are very well. And thanks for your appreciative words about CSIR. Definitely, we are looking forward and how we can strengthen it further. Now, I invite member from Environmental Development Assistance Systems Private Limited.
Yes, sir.
Dr. Isha? Huh? Atulesh? Atulesh, can you hear us? Oh, otherwise we can come back to you later. No problem. So, here, right time, I would like to introduce Dr. BP Sharma, his head HR, and our Dr. Nasreen Ansari, expert in our analytical chemistry division. She's also with us. So now I have kind of another dimensions on capability development. So in that aspect, how important in connecting the industries, or how we can strengthen the industries on skill development for various sectors, and how the pan CSIR level we can contribute for this skill development, particularly training their manpower for industrial equipped manner, or like how we can fine tune their already people are working in the industries. So over to you, sir.
Thank you, Dr. Partha. Very good afternoon to each one of you. And I would like to say in a different way, today is an International Day of Friendship. And when I say to the aspect of the core theme, that is the interventions and toxicology for industrial safety and sustainability. I'm not saying in the toxicological intervention for industrial safety and sustainability. I'm trying to mold it and how to answer the question which Dr. Partha has just said. On my left and right, we have the strong support, Dr. Manikam and Dr. Partha, and the galaxy of the experts from the varied fields. So it was a good start since 10 o'clock in the morning, and we had a bouquet of scientific research and innovations in the different fields, ranging from the quality aspect, environmental aspect, bioremediation, and the industrial connect in the different way. When I see to the word I find the industrial issues, the India, independency, incubation, innovativeness, intelligent. These are the various aspects how we can interact and coordinate with the industry. And this is a particular platform where the bridging the gap between the different race, language, and culture, which becomes an important aspect. When I see to the stability and solidarity in terms of economy, and the trained manpower is the need of the hour, whether it is any of the field where environmental monitoring in the different aspects of the water, air, and food, and so other areas, I can say that whether it is the DSIR, CSIR as such, or any of the industry, they always look for a partnership and creation of a trained manpower for the capacity building. In this scenario, the CSIR IITR is in the forefront. We have been guiding and enriching the manpower from the very base level of intermediate to graduate level to the PG level and postgraduate levels. Giving the sensitization, we have several programs under the CSIR, such as Jigyasa, APIC, and others. So throughout the year, we have the multiple activities ranging from the National Science Day to the World Environment Day to the CSIR Foundation Day and other activities. The name may change, but always our basic concept is to sensitize the children to come into the area of science and to do with excellence. In this particular field, we have the multiple avenues, and whether it is the industrial partner or the partners from the other field of the society, we are taking the multiple opportunities, and they can come, they can learn, and in the incubation center, they can really enrich their knowledge through the help of the scientific community, which is readily available within the CSIR, and especially to the aspect of IITR. If I say our focus is more on the toxicology or to the safety to the environment and with the service to the industry. With these things, we are having also the accreditations with the GLP system, NABL system, which also give a confidence in us that we can do, and this, whatever we do, is having a high level of confidence, high level of accreditation. So these are the avenues. With these few ideas and few thoughts, I look forward for more and more support from the industry. The industry can always ask, there should be a demand and supply. We are ready to take up the challenges. With these words, I thank each one of you for organizing a wonderful program. And this is not just, it will not be an end, it will be a beginning to other aspects of new innovations and new creativity. Thank you a lot. Thank you for giving me an opportunity to share my few words of partnership.
Thank you so much, Dr. Nasreen.
Now you can come. She can come. Okay. Fine.
Good afternoon, everyone. Continuing with what Dr. Sharma said, what I feel for Industry Connect, we need to nurture our basic grassroots level technician or the task force which is coming for our help in the industrial technological development. Once we develop any kind of technological aspect, that needs to be verified, be it in the biological field or the chemical field. That nurturing only comes from the skill development. That skill development is lacking, and because of the quality system have not been incorporated in the school level, though the national education policy is in place, but we need to nurture our grassroots level technicians to a level that we can enhance our technology at the various levels. Once we develop a technology, we come to the analytical scientist or the chemist to get it verified. So that's how we have been doing for past 25 years. IITR has been contributing in this skill development program, and we have at least trained thousands of technicians, trainers, and different level workers at national and international level with through different collaboration. But my experience is, unless until we incorporate quality into the system, we'll not be able to nurture anything or extract out of them any kind of technology. And moreover, we should enhance their idea, and we should promote their idea. If they have idea, they need to be given time and energy so that they can contribute or execute that experimentation, even though it fails. But we'll get some know-how of the technology which can come up for the system, for the remediation of the ecology, which we have been ruining out because of our activity. So that can be one of the things. Further, there are higher advanced analytical equipment and the technical thing which has to be taken care of in terms of analysis, in terms of interpretation, when it comes to a technological finalization stage, that be it air quality monitoring, soil, water, all remediation work is being going on. But unless until there is a instrumental aspect or the analysis done for them, we cannot interpret or say your technology is up to the mark. It can be utilized or reutilized for a longer term, or it can decrease the burden on the energy of the environment for the renewable and non-renewable sources of energy. So that these are the things which we have been doing it, but still nonetheless, we have been in collaboration with all the biological, chemical, and the integrated approach we have done for the different industries also for the training purpose. And we have done training for the specific type of analysis, for the standard type of analysis for the CPCB and MPCPCB and other levels also. So when in that aspect, we have been also doing dissertation work for many of the students. So there our scientists give us the insight how the scientific level at the accredited body works at, be it NABL or GLP. So there are different aspects which can we do for the society for this ICEN-64 program, from the industrial to the nurturing to the skilled manpower. We can move on with that. Thank you.
Thank you, Dr. Nasreen, for very specifically covering these points. Now I request our senior scientist members, Dr. Monikam. So not on, like now we overview of various environmental aspects. CSIR IITR is working on food drug toxicology, regulatory toxicology, and environmental toxicology, system toxicology, health risk assessment, and toxic informatics. So I would like to request our senior scientists to briefly talk about how these divisions can contribute to the industries. and provide final conclusion by Dr. Manu.
Okay, yeah, okay. Thank you. Quickly, it's a long day, though iConnect is very crisp program for planned out half a day. I hope our guests are still there. Just the last point which he brought, I take a word from our younger colleague Dr. Nasreen said one thing, that bringing quality into the system. So be it research or translating the technologies, and way forward. So everything needs a quality in place. IITR is a best an example that, because of these efforts from large number of scientists, we have NABL and GLP in place, and countrywide people look forward to testing preclinical studies and testing in our institute. So that Partha brought in another connotation, that large number of other researchers other than the environmental niche per se, that the other research like health technologies, as I said in the morning, the core toxicological studies, be it pulmonary toxicology, reproductive endocrine toxicology, or even other neurological, neurobehavioral, neurotoxicological interventions and sciences happening. See, any chemical comes into environment, we so far discuss under the E3W theme as a pollutant to be monitored. There should be technological invention. But during this process, the human organisms, communities get exposure to various level through lungs, of course, pulmonary toxicology, or liver metabolism through like hepato toxicology. So in each aspect, handful of scientists are working in our institute. They give large number of molecular mechanisms, systemic approaches, their contamination in various matrices, including food. So, like for example, on my left, Dr. Khanna is sitting there. They work on like individual chemical entity on neurobehavioral aspect or cognitive learning or whatever neurological disorders, neuro diseases, but also bring in molecules which can be looked as an adverse effect or the signals of adverse effect mediated by these large number of chemicals. So what that Partha wanted is how to connect the transdisciplinary domains to deliver, of course, the quality research in the national level. So I took some examples. So development of markers, assessing signal molecules, understanding molecular mechanisms, those things provides a great leap in forward, which is the strength of IITR, as our director Morning put it very clearly, that IITR is in advantageous position where core R&D, transdisciplinary work, and technological development and incubation centers help in tandem to achieve certain things under the theme, at least E3OW. But we scientists are cross-cutting in the domains to deliver what Atmanirbhar goals can be achieved through these research efforts. And of course, Dr. Sharma said, imparting, disseminating large number of this knowledge into younger minds, of course, triggers some passion of in them to come into at least research. That is one thing. Second, take up some of novel thoughts. Of course, like in toxicoinformatics, there are at least 20-30 research scholars putting effort in enrolling the recent developments in computational biology to address these issues, be it big data management or delivering into some of this environmental monitoring in device development. So the truly transdisciplinary work is happening. But with having said that, I personally feel that as Dr. Nodal Director or Team Director Dr. Tiwari said, we need to emphasize on certain things. He presented a bigger roadmap in CSIR, cross-cutting with the national agencies, their involvement. But iConnect event, the way forward, as he said, we need to select few niche areas. See, we have discussed a vast domain, but at least 2-3 immediate technology development, incorporating the scientific capabilities, expertise we have, we should identify 1 or 2 areas and start delivering. That is more important other than the discussion, so that we meet the Atmanirbhar goals. And definitely, as our industrial partner said, the industrial work should also sustain the environment for future generation to live peacefully and happily. That's it, I think. From my
Yeah, correct.
Thank you, sir, for summarizing very briefly. And as sir suggested, we have various programs at mission mode level and sensor development for food adulteration, contamination detection, and environmental pollution monitoring devices development, and various tools and techniques, particularly on pesticides or chemical detection and various toxicological testing parameters, how we can develop upon. So all these aspects currently we are working on. So these are all very relevant to the industries. Actually, so now I request if Atulesh is the one of the missing is not available so far. So if Atulesh can add some points.
Dhirendra wants to raise hand. Anything you want to say?
Atulesh, you want to say something, or Dr. Dhiren? If you want to say something, please.
Yeah, sir. I would like to say something because I try to wrap up thing in a very few time, but now I'll need 2-3 minutes of yours. And first of all, sir, like as an airshed planning professional, so we have developed the capability in air pollution research studies like source apportionment, emission inventories, and even now we have developed the few products. We have developed few products for air quality monitoring, and we have a strength of developing the prototype into a commercial grade technology as well. So we would like to extend our these services to CSIR if they think of somebody has come up with some few things which they need to for the fabrication, or they need some enhancement. So that sort of thing can be we would love to do that. And other part is the services. As far as we have a specialized team of emission inventory, we have a specialized team of sampling, we have the specialized team of GIS professionals as well. So it is we would like to expose our strength to CSIR in a manner like whatever way. If you want to exploit our strength, we are very much we would be very obliged to do that, sir.
Thank you. Thank you.
Dhirendra and Atulesh, can you put on your camera for a moment, please, if possible? And is there Dr. Atulesh is available? Good, sir. Thank you.
So happy to see you, sir. Nice to see.
Thank you. Dr. Atulesh is there? Anybody from Atulesh? Okay, Dr. Partha, please conclude about thank you. Want to say something? Yes, sir.
So thank you so much. We had a very great session on our event today. So it's formally we have come to the final part of this event. At the onset of the completion of ICEN-64 ICEN-64 event organized as part of Azadi Ka Amrit Mahotsav celebration, the Ministry of Science and Technology and Ministry of Earth Sciences, Government of India, under the E3OW theme of ICONIC, on behalf of the organizing committee and as a coordinator of the event from CSIR IITR, I would like to thank Professor S.K. Barik, Director CSIR IITR, for his encouragement and support to host the event and also his valuable time to inaugurate the event. And I would like to also thank the team director, Dr. V.M. Tiwari, Director NGRI, for providing the opportunity to host the event and showcase the potential of CSIR IITR under the thematic thrust of E3OW. I'd like to thank Dr. Viba, TMD, and the entire TMD division for the valuable support, as well as the iConnect team for their very smooth coordination for the event. So immense thanks beyond words to Dr. Monikam and our colleagues like Dr. G.C. Kisku, Vinay Khanna sir, Khan sir, Nasreen ma'am, and Rachna Kumar, and Shrikant, and Dr. H. Khan, and Dr. V.P. Sharma, and my colleagues like research scholars for entirely working for this event. And another important highlight of the day is the industry partnership. So I like to thank all the industries members who participated in the event and made it very, very special for this event. And I thank Dr. Chakradar, Dr. Nandi, and our young industrial members, Alok Gupta, Dr. Virendra Singh, and Ishar Hussain, just joined a little late, but still, thank you so much for the support during on Saturday and the weekend. I thank our computational ICT team headed by Sri Nikhil Garg, Chief Scientist, ICT Department, and the members for the seamless support of IT and facilitation for the event. I thank you all the participants and listeners and enthusiastic researchers joined virtually for the event. And finally, this iConnect event, we hope will work closely together with the industry on the challenging, ongoing as well as emerging issues to solve and provide solution and to serve the nation. Jai Hind. Thank you so much.
Thank you.
Thank you. Thank you, sir.
Thank you. See you all later. Okay. Bye.
Thanks, host.
चलिए खत्म हो रहा आपको बुलाया जा रहा। अरे हम तो प्रोफाइल